Hey grade 12s and welcome to this video. So in this video, we're going to be working on the NSC Mathematics Paper 1, May to June 2023 paper. Okay, so this paper is for 150 marks and it is 3 hours. Although this video may be longer than 3 hours because it takes a bit longer to explain rather than just really think it through and write down the answers. Also, I plan on making this just one single video, but I'm not really making promises. So if you're watching this video and it's just like question 1 or it's based on just functions, then just know that the plan on making it one video didn't work out. But I will try my best to release it as one video. Okay, so without wasting any more time, let's go on to question. So question 1, this is what we have. So we are told to solve for x in 1.1.1. You're given a trinomial and you have to just factorize this trinomial. Remember, you can use the quadratic formula, but you will lose 1 mark for your factors. So rather use the quadratic formula like this. But first, let me show you the right way to do it. So first, you're going to open up 2 brackets and we're equating it to 0. Then you're looking at the first term, it's x squared. So what multiplied by what gives you x squared? That will be x multiplied by x. And then the second term is a 12. So what times what gives you 12? Well, a number of things would give you 12, like 6 times 2, 3 times 4. But you also have to think about the fact that this is a positive 12. The only way you could have gotten a positive is if you said positive number times a positive number. Then you would get a positive. Or you could have said a negative number times a negative number, and then you'd also get a positive. And now, as you can see, between these two, which one can we pick? It's definitely going to be the negative times the negative, because you see that the middle term is negative. If it was the positive times the positive, then we shouldn't have any negative in here. Okay, so it must mean that 2 of these numbers must be negative. So think about it like this. If you had negative 6 minus 2, because they both need to be negative, and when we add them, they should give you the middle term. Negative 6 minus 2, that is negative 8, which is not the middle term. We need to have a negative 7. But if you said negative 3 minus 4, then we get negative 7. So these are our factors. Our factors are negative 3 and negative 4. So it's negative 3 and negative 4. Okay, and then you just solve for x after this. So we're just going to simply say that x is either equal to a positive 3, because remember it's like taking that over the equal to sign, or x is equal to positive 4. Okay, so that's the right way of doing this. But if you wanted to use the quadratic formula and still get marks for your factors, because they give you a mark for your factors, this is 3 marks. You get a mark here for your factors and you get a mark for each answer. So if you wanted to use the quadratic formula in a way that you still get all your 3 marks, this is how you should use it. First of all, do not write down the quadratic formula. If they see it, then it's like, I didn't factorize. So what you're going to do is you're going to put it on your calculator instead. Remember, the quadratic formula is negative b plus minus the square root of b squared minus 4ac over 2a. So on the calculator, so even if you just write this in pencil, but then you can erase it after, then it's fine. So you can say negative, and then we'll open a bracket. The value of b is negative 7. So yeah, that's your b. And your a, because we had x squared here, then it means that a is just a 1, an invisible 1. So that's a. And then c is, of course, the 12. So we're just going to put that into the quadratic formula accordingly. So when I put this into the quadratic formula, just please notice that I use the minus first. So not the plus, I use the minus first, just because it's a smaller factor. Okay, so when we put minus, you get 3. Now you need to remember, 3 is your solution. That's when you're saying x is equal to 3. You still need to create 2 brackets. So I'm just saying, imagine you didn't have this. Still have to create 2 brackets and say is equal to 0. And so if one of your solutions is 3, then it must mean that your factor must have been x minus 3. So that when you say x minus 3 is equal to 0, you take the negative 3 over and it gives you a positive 3. And then, of course, to find the other factor or the other solution for x, we're just going to change that negative to a positive. And then you see you get 4. So it's a positive 4 as your solution for x. So it must have meant that you must have said x minus 4 as your factor for that to be your solution. So that's the way to use the quadratic formula. Even if you didn't factorize, then you would still get a mark for your factors and for each answer. Okay, so that's it for 1.1.1. Moving on to the next question. And then 1.1.2, where we're actually supposed to use the quadratic formula. So we have this equation, and the minute they say correct the 2 decimal places, you know you have to use the quadratic formula. Okay, so there is something that you just have to do here. You have to simplify this a bit further. Because x is in front of this, and they are brackets, it means that they've been multiplied. So we're just going to FOIL this in. We're going to multiply that in. And so we have x times 3x, that is 3x squared, and x multiplied by positive 5, that is positive 5x. Then we have this equal to 1. But remember, we must always have one hand side equal to 0 in a quadratic equation so you can solve for x. Okay, so I'm going to take the 1 over, and we have minus 1 is equal to 0. Okay, so correct the 2 decimal places, just use the quadratic formula. And that's the quadratic formula, and let's just figure out what A, B, and C are. So as you can see, 3, that is the value of A. And then 5, positive 5 is the value of B, and the value of C is the constant without any variable, which is negative 1. So you're just going to substitute all of those values in. So we say negative, and we're putting in the 5 plus minus the square root of the 5 squared minus 4 times A, which is 3, times C, which is negative 1, all over 2 multiplied by A, which is 3. So put this onto the calculator and get your solutions for x. So we finally have here x is equal to negative 1 comma 8, and we have to round off to 2 decimals. So the 7 is going to round up, causing that 4 to become a 5. So it's going to be 8, 5. Or, and then just go ahead and change that minus to a plus, and we're going to have 0 comma 18 rounded off to 2 decimal places, so 0.18. Okay, now moving on to the next question. And 1.1.3, we have an inequality. We have x squared is less than negative 2x plus 15. Now, because x squared is positive, you can just go ahead and take these two terms over to the left hand side. So we're just going to have x squared, and then that will become a positive 2x, and that now comes over and becomes a minus 15 is less than 0. And then you have to factorize this. So we're going to open up 2 brackets and say less than 0. So we're going to have x and x, which gives you the x squared. And we need factors of 15. So think about factors of 15. It can be 1 and 15, but that's definitely never going to give you a 2, so we can even just leave that out. Then you can think about 3 and 5. Okay, so that can definitely give you a 2. Remember, the 15 is negative. The only way you can get a negative number from these two is if one of it was positive and one of it was negative. But you have to choose which one should be positive and which one should be negative so that you can get that middle term as a positive 2x. So imagine you have a 3, you have a 5. If you made this negative 3 and you made this positive 5, then this will definitely give you a positive 2, because positive 5 minus 3 is 2. Okay, so that's how it should be put. We're going to have negative 3 and positive 5. Okay, so those are your factors. You can also use the quadratic formula, but just don't show them that you did that. So like I did in the first question, you can also do that. Okay, now that we have the factors, this is what we can do. So in grade 11, in the past, in grade 11, they used to teach this method of having a number line and then, putting in the numbers and stuff like that. These days, I noticed that teachers don't really use that method anymore. They're using more of a grade 12 method. So you can use this method. Say that we have x squared plus 2x minus 15. This forms a parabola, specifically a concave up parabola. So a parabola that looks like that. So this is what we're going to do. And then you need an x-axis. That's all you need. You need the parabola and the x-axis. Then on the x-axis, we're going to have our critical values. And we get our critical values from these. It's like solving for x. So it's like when we say x minus the 3 is equal to 0. And then you take the 3 over, so you get x is equal to 3. But in this case, I'm not saying x is equal to 3 because this is not an equation, it's an inequality. So I'm going to have to solve for whatever that sign is going to be in the middle. Then I'll do the same to the second bracket. Or So the second bracket, we're going to do the same thing to that. We have x plus 5, so I'm going to put down x, and it's like taking the positive 5 over the equal to sign, so you have a negative 5. Okay, so we're going to just solve for x here, but it's not an equation. Now, on your number line, your x-intercepts, these values over here, those will be your critical values. So the one that will go here, because this is more to the left, it will be the smaller one, which would be the negative 5 that will go here. And the 3 would go on this side. And now you have to focus on this. So you see that it's saying that this expression needs to be smaller than 0. Now, what they mean when they say it's smaller than 0, this is referring to the y values of this graph. The question is basically asking you, find the x values where the y values of this graph is less than 0. So for the sake of understanding, usually we don't need a y-axis, but just for the sake of explanation, I'm going to draw a y-axis. So let's say we had a y-axis here, right? I know it may not be in the middle here, but I'm just saying. So if this is our y-axis, think about on this y-axis, let's think about the kind of values we can have. If you look here, these values over here, these are values that are greater than 0. So these are positive values. But they want where the y values are less than 0. So where they're less than 0, that will be here. So you're only going to look at the part of the parabola that has y values that are less than 0. So if you're looking at the parabola like this, on this part, you see all of these parts here, look at their y values. That's the y value of that point, and that's the y value of that point. These are all y values that are greater than 0. So we're not going to take any of this. But if you go down, you see now this point, look at its y value. This point, look at that y value. These are all y values smaller than 0. And then when you get to this point, we cannot take any part of this because these all have y values greater than 0. So you're going to highlight the one you're going to take. We're going to take everything here. So all of these y values. So this is the only part of the graph we're going to focus on. And now you're going to take these parts of the graph and line them up to the x-axis. We want to see, like for example, this point. What is the type of x value it has? Look at its x value. Its x value is here. Okay. And then this point over here, look at where its x value is. And this point, that's its x value. So it's kind of lining up the points to the x-axis so that we can see the type of x values they have. And now when we have done that, we're going to compare to the critical values. You see, we have negative 5. And the x values that belong to the shaded part of the graph, they are on the right-hand side of negative 5. So these values are what than negative 5. These values would be greater than negative 5. And that's really our solution when we're looking for x and negative 5. We are saying that x needs to be, the solution needs to be values that are greater than negative 5. So we're saying x is greater than negative 5. And also just notice, you see the inequality and look at the arrow of where your solutions are. You will notice that that arrow is going to help you to show you how your inequality is going to look. Okay, so it's the same sign. And then you're going to do the same thing to the 3. So we're looking at the 3 and we're saying, what are the values that we have? You see that these are the values we have here. They are on the left-hand side of the 3. And values on the left-hand side of the 3 are values that are less than 3. So when we're looking at x compared to 3 over here, we're saying that x needs to be smaller than 3. So x is less than 3. So as you can see again, the sign, okay, that arrow is helping you to see what your inequality is going to look like. Okay, so now that we have this, there's one more thing you need to do. So sometimes you can conclude further. You can actually write this together sometimes. And this is how to see it. So look at the graph. Look at the x values that we have. Notice that they are pointing towards each other. These arrows are pointing towards each other because they're speaking about a related set of values. Values that are greater than negative 3 but smaller than 3. And because these values are related, You see, they're not pointing in the opposite direction. We're not speaking about x values that are greater than 3 and x values that are smaller than -5. Then they wouldn't be related because they're just pointing in the complete opposite direction. But these ones are pointing towards each other. So they're speaking about the same set of numbers. So we can write them as a whole. So just remember, only ever do this when you see that the values are pointing towards each other. Okay. And now we can basically write this like this. You're going to put the x in the middle, and then on the left hand side, you're going to put the smaller number. So that is the -5. On the right hand side, you're going to put the bigger number, which is the 3. Then you're going to look at, when we have here -5 and x, you're going to also look at the x compared to the -5. The inequality. So this is an inequality. Just notice that that is the mouth. That's what I'm going to call the mouth of the inequality. So when you're looking at x versus the -3, where is the mouth facing? You see it's facing the x. So you have to write it like this. The inequality, when you're looking at x versus the -5, see the -5 and the x, the inequality needs to face the x. And do the same thing to the x and the 3. When you have the x and the 3, notice the inequality, the mouth is facing the 3. So we're going to say x is smaller than 3. Okay, so this is really saying that x is greater than -5, but smaller than 3. You read it from the middle to the left, then to the right. And that's our answer in 1.1.3. Then in 1.1.4, we have an equation with surds. Okay, so in this equation with surds, when you're solving equations with surds, the first thing to do is, you need to solve for x. And what is stopping you from solving for x is this square root that we have. So we need to get rid of that square root. And you basically do that by squaring both sides of the equation. So we're going to take that and square it, because what you do on one side, you must do on the other side. And so that breaks open that surd because they're the inverse of each other. So we just have the 2 brackets 1 minus x is equal to, and of course we have that x minus 1 all squared. Okay, so this will just FOIL in, and so we have 2 minus 2x is equal to, when you are simplifying this, it takes long to just go x minus 1 and x minus 1 and start FOILing out. So something you can do is this. Take the first term, whatever that is, it's x, square the first term. So that will be x squared. Then to get the last term, you take the last term that we have here, -1, and square that. So -1 all squared is going to give you a +1. Then to get the middle term, you're going to take the first term, which is the x, multiplied by the second term, which is the -1. So you get -x. Then you multiply that by 2. So that will give you a -2x. So you can FOIL it out the normal way. You will see that you will get this answer at the end. Okay, so now that we have that, we can go ahead and say we have, since I have x squared on this side, I'm going to just take everything over to that side, because you can see this is going to become a trinomial. So we're going to be left with nothing here. 0 is equal to x squared, and we have the -2x. Then this -2x comes over and becomes a +2x. And then we have a +1. And then this +2 comes over and becomes a -2. So this is what we have. 0 is equal to x squared. The -2x and the +2x would cancel. And then we have a 1 minus 2, which is -1. Okay, so this is what we have. X squared minus 1 basically equal to 0. There's two ways of solving this. You can solve this the difference of two squares method, seeing that this is a case of difference of two squares that you have to use to factorize this. So we're going to say open up two brackets, and we have, first we have x minus 1, and then we have x plus 1. And then we'll just solve for x by saying x is either equal to, so we're taking this -1 over and we get a +1, or we're saying x is equal to taking that +1 over and we get a -1. Okay, so that is one way of solving for it. Another way is you could have done this. So if you didn't want to use difference of two squares, you could have done this. So we can take this -1 over instead. And so we're going to have a 1, +1 is equal to x squared. And now to solve for x, you have to get rid of the square root, and the only way to get rid of it is to square root both sides. But this is an equation. And if you're saying that x squared is equal to 1, well, you have to remember that, yes, if you say 1 squared, you're going to get 1. But if you also say negative 1 squared, you're also going to get 1. So in front of this, you have to consider that you're going to have a positive and a negative answer because we're square rooting both sides. So we're going to say plus and minus. Another way of looking at that is the fact that because we have a squared on top of the x, it means you have two possible solutions for x. So you have to consider the positive and the negative one. So it would mean that x is either equal to the positive or the negative square root of 1. So the square root of 1 is 1. So it means it's either equal to positive or negative 1, which of course you can write like this. X is equal to negative 1 or x is equal to positive 1. Okay, so we've solved for the surd. Now, there's one more thing you always have to do when you solve for surds. You have to check if your answer is correct. So you're looking at the two solutions that you have, and you're going to individually take them and substitute it into the original equation. So this was the original equation. It was the square root of, we had 2 bracket 1 minus that x, okay, which I'm going to leave it open, is equal to, and then the x minus 1. So we're going to try both answers. Let's try first the negative 1. That's our first solution for x. So we have 1 minus the negative 1, and then here we're going to have the negative 1 minus 1. So go ahead and see what you get. The equation needs to balance. We have to have the same thing on the left that we have on the right as well. So you see that on the left hand side, if you put that into the calculator, you're going to get a 2. But on the right hand side, negative 1 minus 1 is negative 2. So that's not true. The equation is not equal here. So because it doesn't make the left-hand side equal to the right-hand side, then x is equal to negative 1 is not a solution. You can go ahead and cancel and say x is not equal to negative 1. Okay, you can also try 1. It's probably going to work, but you can still try it as well. So in place of that empty spot, if we put 1 instead and 1 here, let's see what we get. So on the left-hand side, you see you're going to get 0. And here, 1 minus 1 really is 0. So you see that that works. So x is equal to 1 only. Okay, it's not equal to this one. So that's something you always have to check. Okay, so that is the final answer there. X is equal to 1 only. And then we move on to the next question. Okay, so moving on to 1.2, we have to solve for x and y simultaneously. And these are the two equations that we have. So I know that normally they give you a linear equation and then another equation, and you usually just make the linear equation equation 1. So if they give you this one that looks like an exponential equation, you make this one equation 1 because this one can actually form a linear equation. So we're going to call this equation 1 and we're going to call that equation 2. Then from equation 1, which is 3 to the power of x plus y is equal to 27, we're going to form equation 3 by making either x or y the subject. Now the way to do that, because we have 3 to the power of this, and then we have a 27. Okay, since this is an exponential equation right now, we can make their bases the same. So 27, we can rewrite 27 as 3 to the power of 3. And now that the bases are the same, we can equate the exponents. So that therefore means that x plus y is equal to 3. And now from this, you can make one of it the subject, either x or y. So I'm going to choose to make x the subject. X is equal to, and I'm saying 3 and taking the y over minus y. And so this is now equation 3. And then we're going to substitute equation 3 into equation 2. So the equation that we didn't use yet. And so wherever you see x, you're going to replace it with 3 minus y. So we have an x squared. So I'm just going to say 3 minus y all squared. Then plus we have y squared is equal to 17. And let's go ahead and solve for y here. So now we have this. Now this is a square binomial. You can of course go ahead and say 3 minus y multiplied by 3 minus y and then FOIL out everything. Or you could do this instead. So you take the first term and then we're going to square that. So it's like saying 3 all squared. That will give you a 9. Then you take the last term, or the second term, which is negative y. So it's like saying negative y all squared, which will give you a positive y squared. Then we're going to take the 3, the first term and the second term, and multiply them. So 3 times negative y is negative 3y. Then you're going to take that and multiply it by 2. So negative 3y times 2, that is negative 6y. Okay, remember that is positive y squared, so that's a plus there. And then we still have plus y squared is equal to 17. Okay, the y squared and the y squared, I'm going to start with those because I want to put it in the order of their exponents. So we're going to have 2y squared, and then we have the minus 6y. Then on this left-hand side, we still have a positive 9 here. And here we have a 17. This 17 can go ahead and come over. So when we take the 17 over, we're going to still have the positive 9, and the 17 comes over, becomes a negative 17 is equal to 0. So 2y squared minus 6y, and then 9 minus 17. Okay, so that's negative 8. So minus 8 is equal to 0. Okay, so we have a trinomial in terms of y. But if you look throughout this trinomial and look at all the terms, notice that everything can be divided by 2. So we're going to take both sides of the equation and divide it by 2. So we will have just a y squared, and then negative 6y divided by 2, that is negative 3y. Negative 8 divided by 2, that is negative 4, is equal to 0. So here's your trinomial. You can use that quadratic formula, or you could factorize it. So open up 2 brackets, and we're saying it's equal to 0. Y squared. What times what gives you y squared? That's y times y. And then negative 4. What times what gives you 4? That is 4 times 1. But because it's a negative, it means one of it needs to be negative, one needs to be positive. So if we say negative 4 and put that as positive 1, then negative 4 plus 1 will give you your negative 3 in the middle. So our factors is the negative 4, and we have the positive 1. And so we can go ahead and conclude that finally here y is finally equal to a positive 4, or y is equal to negative 1. So we have equations for y now, and we ended at equation 3. So this can be equation 4. And lastly, in order to get the x values, because we have the y values, you're just going to take equation 4 and you can substitute it into equation 3, because equation 3 has x as a subject. So we're going to substitute equation 4 into 3. And so this is our equation 3. And so in place of y, we're going to first put in 4. So that is our y value there. So x is equal to 3 minus 4. So therefore x will be equal to negative 1. And then we have also, or x is going to be equal to 3 minus, and then the y is negative 1. So bracket negative 1. So x is equal to 3. And then if you have a negative times a negative, it gives you a positive. So that is positive 1. X is therefore equal to 4. So those are solutions for x and y. So when x is equal to negative 1, your y value is equal to 4. And when x is equal to 4, the y value is negative 1. Okay, remember these just form graphs, and you're just finding the points of intersection, because those be the only places where these two equations are equal. Okay, so that is our solution. Moving on to the next question. So question 1.3, we have to determine without the use of a calculator the value of 1 over the square root of 1 plus the square root of 2 plus, and then this basically keeps going all the way to 1 over the square root of 99 plus the square root of 100. Okay, so I know this type of question in question 1 is really something that would scare most people, because you're in a state of sort of panic. And that's why in your exam papers, you need to try your best to have a calm mind, no matter what. Because when you panic, you don't really think very well. You think better when you are calm than when you panic. So you need to walk into that exam room as if you wrote the syllabus. But again, for you to have that kind of confidence, you also have to have really studied and really practiced. Okay, now the thing about this question, it's using a grade 11 concept. When we have a surd on the denominator, for example, let's say we had something like this, 1 over the square root of 2. Notice that on your calculator, not really this calculator is kind of programmable. It's not going to really work on here. But on your calculator, if you write 1 over the square root of 2, you're going to notice it's going to simplify it for you. Okay, so you see, mine will not do that. But yours will simplify it to the square root of 2 over 2. So what it's doing, it's rationalizing the denominator. This is a concept that is actually taught in grade 11. And that's the thing about matric. It is a mix of grade 11 and grade 12. So when you rationalize the denominator, it's in the word rationalizing the denominator, you're making the denominator a rational number. Because right now it's a surd and that's irrational. So you make it a rational number. And this is how we do this. So when we have 1 over the square root of 2, to make this a rational number, you would really just say multiply by the square root of 2 times the square root of 2. And really what we're doing is we're multiplying this fraction by 1. But in the form of the square root of 2 over the square root of 2. That's actually what we're doing, because that would give you 1. And so when we do that, you see that 1 times the square root of 2, that gives you the square root of 2 over square root of 2 times square root of 2, that is 2. And that's how we get that. Now, the thing about what we have here is this is not what the denominator looks like. The denominator is not just the square root of 2. It is the square root of 1 plus the square root of 2. And the next one is the square root of 2 plus the square root of 3. And this keeps going. So this is how to rationalize things with two terms that are surds on your denominator. So if we have 1 over the square root of 1 plus the square root of 2, what you can do to rationalize this is we're going to multiply it by 1 again, but this time in the form of the square root of 1 minus the square root of 2. Okay, over the square root of 1 minus the square root of 2. Now I know, looking at this, you would have thought maybe you have to multiply by 1 square root of 1 plus the square root of 2 over the same thing. The thing about this is if you multiply that denominator by this, okay, so you can just see it on the side. If you said square root of 1 plus the square root of 2 and you multiplied it by this, it will not become a rational number. Okay, when you're multiplying these two terms, they're really binomials, so they have to be FOILed out. So this would multiply and become 1. That would multiply and become positive square root of 2. So you can be checking these answers on your calculator. That will multiply and become positive square root of 2. That would multiply and become 2. You see, you have a 1, you have the 2, that becomes a 3. But then the square root of 2 plus square root of 2 is 2 square root 2. As you can see, this is not a rational number. This is irrational. It still has a surd. That's why we don't multiply by this. We multiply it by the other thing instead. We multiply it by this. And the reason we're doing this is it's like you're trying to form difference of two squares using this. So if you look at the denominators, and the only reason I'm doing this is so that I won't have to do this for each and every term, you're going to see they're all going to simplify to similar things. So when we have the square root of 1 plus the square root of 2, and you're multiplying it by the square root of 1 minus the square root of 2, what is going to happen is this. Notice you have the exact same first and second term. The only difference is the signs. This should remind you of the difference of two squares. So because of this, even if you FOILed out, which you shouldn't, it's going to take so long. What's going to happen is the first two terms multiply and become a 1. The second two terms multiply and become negative square root of 2. That multiplies and becomes positive square root of 2. That multiplies and becomes negative 2. You can check this on your calculator as well. You will notice that the two middle terms, they have the inverse operations of each other. Positive square root of 2 and negative square root of 2, they will cancel and become 0. So you really just have a 1 minus 2, which is negative 1, which is a rational number. That's the whole point, to make the denominator become a rational number. So now, just so that you don't have to start FOILing out, this is what you can do instead. The minute you see that you have these two brackets multiplied, and you can see they're the same first and second term. The only difference is we have a plus and a minus here. Know that that is difference of two squares. All you have to do is multiply the two first terms, that gives you 1. Multiply the two last terms, that gives you negative 2, and that gives you finally negative 1. Okay, so that's what we're going to do to those denominators. Okay, so we're multiplying it by 1 in the form of this so that we can simplify this and make the denominator a rational number. So on the top, we see 1 multiplied by the square root of 1 minus the square root of 2. 1 multiplied by anything really just stays the same thing. So we just have the square root of 1 minus the square root of 2. Over, remember these two are being multiplied. Remember we have difference of 2 squares because the first term and the second term being exactly the same, only you have a plus and a minus. So that just multiply the first terms, 1, multiply the second terms, that becomes minus 2, and you can see that that will become a negative 1 on the denominator. So square root of 1 minus the square root of 2 over negative 1. And now when we simplify this, you see the two numerators, the terms on the numerator, they have to divide by this single term on the denominator. Each of them need to divide by it. So we're saying the square root of 1 divided by negative 1, which will really just give you the negative square root of 1. And then the negative square root of 2 divided by negative 1. That negative and negative will become positive. So it's a positive square root of 2. I know this can simplify to negative 1, but I'm just going to leave it as a surd for now. So it really just means that this first term, all it is this. Okay, so since we found the first term, let's go ahead and find the second term as well. So here we have 1 over the square root of 2 plus the square root of 3. And we need to rationalize the denominator. And you will rationalize the denominator by multiplying it by its denominator, but instead of having a plus, we're going to have a minus in the middle. So we're multiplying it by 1 in the form of the square root of 2 minus the square root of 3 over the square root of 2 minus the square root of 3. So when we multiply the numerators, 1 times anything stays the same. So we still have the square root of 2 minus the square root of 3 over. Here you just multiply the square root of 2 times the square root of 2, which is 2, positive square root of 3 times negative square root of 3, negative 3. Then we still have the same numerator, and over that will become negative 1. And when you divide both terms in the numerator by negative 1, we get this divided by negative 1 is negative square root 2. This divided by negative 1 becomes positive square root 3. Okay, so that's what this simplifies to. So you see, this is the first term. That is the second term. You're going to start noticing a pattern with the way these terms are going to look. So the first term became negative square root of 1 plus the square root of 2. So when you have this, you just focus on the denominator and you know that the first one is going to become negative, and we still have the same thing, square root of 1. And then the second one really just stays positive. Same thing here. The first term here became negative, the negative square root of 2. And then that still stayed the positive square root of 3. So that would mean that term 3 is going to become this. The first term in term 3 is going to be the negative of this. So negative square root of 3. And then the second term will just stay plus the square root of 4. And this will keep going up until the last term, and they gave us a last term. So this last term, the first term is going to be the negative square root of 99. And then the last term will stay plus the square root of 100. So this is the sequence that we now have. And in this sequence, notice what keeps happening. We have first the negative square root of 1. Then we have a positive square root of 2, then a minus square root of 2. Then in the next term, a positive square root of 3, and then a minus square root of 3. So you can see that each term will always have something from the previous term. It will always have that previous number. Okay, so because of that, what will happen is this positive square root of 2 will cancel with this negative square root of 2. They will become 0. The positive square root of 3 would cancel with the negative square root of 3. They also become 0. That also means that this positive square root of 4 would cancel with the next negative square root of 4, because that's what's going to come after. So if we have a positive square root of 4, we will have a negative square root of 4 after that. And then now looking at this, think about what the previous term before this one would have been. So if this is the last term, the previous term would have been the negative, it always starts with a negative, the negative square root of 98, then would have had a positive square root of 99. So you can see that this would cancel with this. And here, this negative square root of 98 would have cancelled with the previous term's positive square root of 98. So you see that everything is going to cancel in between except for the first term and the last term, because they are the only ones of their kind. These are the only numbers that are not going to be repeated again. So we're going to have is equal to, we just have the negative square root of 1, and we have the positive square root of 100. And this will simplify to this. So negative and then square root of 1. The square root of 1 is 1. So this is just negative 1 plus the square root of 100 is 10. So you can read this as positive 10 minus 1, which is equal to 9. So that is our final answer for that. All of this just adds up to 9. Okay, so that is the end of question 1. So moving on to question 2. Okay, so now we are on question 2. So question 2.1 says, given the geometric series, and we have 1 over 5 plus 1 over 15 plus 1 over 45, and this keeps going. 2.1.1 says, is this a convergent geometric series? And you have to justify your answer with the necessary calculations. So for a series to converge, a geometric series to converge, you need to show that the ratio, the common ratio, is greater than -1 but smaller than 1. So the next thing to do is just to find that common ratio. To find the common ratio, you can just say term 2 divided by term 1, or term 3 divided by term 2. So in this case, term 2 is 1 over 15. I'm going to divide this by 1 over 5. And you see that gives us 1 over 3. So if our ratio is 1 over 3, then truly 1 over 3 is a number that is greater than -1 but smaller than 1. And so therefore this series is convergent. Okay, so we can just conclude that. So that is 2.1.1, and we can move on to the next question. So 2.1.2, they want you to calculate the sum to infinity of the series. Okay, so since the series does converge, you can calculate its sum to infinity. So the sum to infinity formula is just the sum to infinity is equal to a over 1 minus r. Okay, so we're going to go ahead and find a. The a is just our first term, which is 1 over 5. So it just means this is 1 over 5 being divided by 1 minus our constant ratio is 1 over 3. So this is really just 1 over 5 and then divided by 1 minus 1 over 3. That you can see that as like 3 over 3 minus 1 over 3, which is going to be, so if you think about it like 3 over 3, 3 minus 1 is 2 over the denominator stays the same because we're subtracting. So what is 1 over 5 divided by 2 over 3? That gives us 3 over 10. So the answer is just 3 over 10. That is the sum to infinity. So when you sum up the infinite amount of terms that we have in this series, the final answer, it will sum up to 3 over 10. Okay, so we move on to the next question. Okay, and then 2.2, we have an arithmetic and a geometric sequence are combined to form the pattern, which is given by Pn is equal to, so we have x, then 1 over 3, then 2x, then 1 over 9, then 3x, then 1 over 27. Okay, so it's just a combined arithmetic and geometric sequence. The first question is for you to write down the next two terms of the pattern. So of this pattern, okay, since it's alternating between arithmetic and geometric, we're just going to look at it like this. Since this was 3x, notice it keeps increasing by x. That's what the arithmetic pattern keeps doing. We have x, then 2x, then 3x. So it means the next term after this, we will have an arithmetic here, which will be 4x. So we're going to have 4x, and then after that, we're going to have, so we have 1 over 3, then we have 1 over 9, then 1 over 27. So we have x next. Then the geometric that will come after this, notice that these terms, look at the denominators. They will be multiplied, the denominators are being multiplied by 3. So it means that each term is being multiplied by 1 over 3. That would be your ratio. So 1 over 3 then times 1 over 3 will be 1 over 9 times 3. 1 over 3 will be 1 over 27. Then if you say 1 over 27 times 1 over 3, we're going to have 1 over 81. Okay, so we have 1 over 81. That would be the next two terms in this pattern. Okay, then 2.2.2 says determine the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. Okay, so the odd terms. So by odd terms, they probably mean like this is term 1, but it's actually going to be in terms of p. So we're looking at this as this one is p1, and then this one would be p2. Let me actually just write this out. So we have p1, and this is P2 and P3, P4, and this keeps going. We have P5 and P6. So by them saying odd terms, they're probably referring to the terms with term numbers that are odd. Like 1 is a odd number, and 3 is an odd number, and 5 is an odd number. And I think what really makes us know that that's definitely what they mean is because they say write down your answers in terms of x. So notice that the odd terms like P1 and P3 and P5, these are the terms that have x in it. That's the arithmetic pattern. So we just need a formula for the arithmetic pattern. So because these are our odd terms, this is the first term of the odd term, and then second term, and then third term. The formula for this pattern, it's actually a really simple formula, but you can find it the usual way. So because it's an arithmetic pattern, so the general formula of arithmetic patterns are Tn is equal to a plus n minus 1 d. Okay, so your first term, a, that is the x. So Tn is equal to, we have x plus n minus 1, and then our difference. So notice the difference that we have. If you say 2x minus x, you get x. 3x minus 2x, you get x, or 1x. So our difference is the x. So what's going to happen here is we really just have this. We have x plus, now remember this needs to actually multiply into these two terms here. So we're saying the x times the negative 1, which will give you a negative x. And then with the x multiplied by that n is going to give you a positive xn. Then these two would cancel and you're just left with xn. So Tn is equal to xn. That would be the formula for the odd terms of this pattern. Okay, so that's that question. Moving on to the next question. So 2.2.3 says calculate the value of P26. So P26. So we need to find out what will the 26th term of this pattern be. Let's think about it like this. Notice that the terms with odd numbers like P1 and P3 and P5 and P7 and P9, all of those would be the arithmetic pattern of this formula. Okay, but also notice now that the even numbers, so P2 and P4 and P6, all of the even terms, okay, would be the geometric pattern. So it means that P26 is definitely in the geometric pattern. So now we just have to find out which term exactly in the geometric pattern is this, because we know that P2 in the geometric pattern is term 1 of your geometric sequence. P4 is term 2 of your geometric sequence. P6 is term 3. So let's actually just put it like this. I'm going to be calling it, so because this is P2, okay, but it is the first term of the geometric pattern, I'm going to call this G1, as in geometric pattern term 1. And then this one, P4, is our second term of our geometric sequence, okay? So I'll call that geometric sequence term 2, so G2. And I can call this one, the P6, that's going to be G3. Notice what's going on here. Where you have P2, that's your G1. Where you have P4, that's your G2. Where you have P6, that's your G3. The term number is going to be half of this term number. So if this is P6, this is G3. That would mean that if we have P26, and let me actually just put that in green, P26 would be G of whatever the half of 26 is. Because you see, they keep halving. Half of 6 is 3. Half of 4 is 2. So it means that this would be G, 26 divided by 2 is 13. So it's the geometric pattern, but the 13th term of your geometric sequence. Okay, so how do we get the 13th term of your geometric sequence? So we can just use the Tn formula for that. The Tn formula of a geometric sequence is Tn is equal to a multiplied by r to the power of n minus 1. And we want specifically this, the 13th term in the geometric pattern. And so that would be P26 of this entire pattern. Okay, so that is going to be term 13 is equal to the a value. What's the first term in your geometric sequence? The first term in the geometric sequence is 1 over 3. That's G1. So we're going to have 1 over 3 multiplied by our ratio. So you can find the ratio. Your geometric pattern is these orange ones. If you take 1 over 9 and divide it by 1 over 3, you're going to get 1 over 3. So r is 1 over 3. So to the power of n, our n value, that's the 13th term. So 13 minus 1. And so let's see what this gives us. Term 13 is equal to, and this is what it gives us. It gives us 1 over, and let me just see, 3. So this is already in 1 million. So it's 1,594,323. Okay, that is the 13th term. But remember, they want you to calculate this P26, so you must answer them like that. So because we know the 13th term in the geometric pattern G13, that's actually P26. So we can write that down. We're saying therefore P26 is equal to that 1 over 1,594,323. So that's our answer. Okay, and I'm not going to round this off because this is a term value. If you round it off, it's not going to be this fraction anymore. And if you round this off, it's going to become 0. And that term value technically is not 0. It's just so small, it looks like 0. Of course, because as you can see, the geometric pattern is converging. The ratio is 1 over 3. So each term after will just get closer and closer to 0. But because of the nature of numbers, it's never really going to become 0. It just grows infinitely smaller. Okay, so moving on to the next question. And then we have the last question in question 2.2.4. For 6 marks, they want you to do this. If sigma, we have sigma the sum from n is equal to 1 all the way to n is equal to 21 of Pn, so that pattern is equal to 33,3. We need to determine the value of x. Okay, so the thing about this question is you need to remember that Pn, the pattern that is defined by Pn, is made up of 2 types of pattern. So we have a geometric pattern and we have an arithmetic pattern. So in order to find the entire sum of Pn, you need to separately find the sum of the geometric pattern and then the arithmetic pattern, then add it together, and it should be equal to 3.5. And that will cause an equation where you need to solve for x. Okay, so we're going to work on these 2 patterns separately. So let's find the geometric one. So that you don't beat around the bush and you don't look for things that you don't really need, what you can do is write down the formula of the sum of geometric series. Now, I know, yes, this geometric sequence, as we can see, it does converge, but they don't want you to find the sum to infinity. They want you to find the sum of it till, 21, but that is of Pn. Okay, so since we need the sum of the geometric and the arithmetic, let's just do it like this. We're going to find the Sn formula of this. So it's going to be Sn is equal to a bracket 1 minus r to the power of n over 1 minus r. Okay, so using this formula, you can also use the other formula. It will work out. So you can use this formula, but I specifically like to use this formula when I see that the ratio is smaller than 1. So looking at this formula, you see the first thing we need a. And a is, of course, the first term. So we need to know what the first term is in the geometric sequence. So in the geometric sequence, and I think I'm just going to be calling this the G sequence. So in the geometric sequence, you see that the first term is 1 over 3. So in that, we have a as 1 over 3. Our ratio, we already found that that was 1 over 3. If you take the next term of the G sequence and you divide it by the first term, it's going to give you 1 over 3. So that's the ratio. Constant ratio is also 1 over 3. Then we need to find n. Now, you need to remember n means the last term in your geometric sequence, because we're going to find separately the sum of the entire geometric sequence, okay, in that pattern when they say that this Pn, like the pattern combined, ends at 21 terms. So we need to find the last term in this geometric sequence. It's not 21. What is ending at 21 is the Pn pattern. So this entire pattern combined, that ends at P21. So what we can do is find out where is the geometric pattern ending and where is the arithmetic pattern ending. Okay, so since the last term that we have here, what they ask us for is 21. So that is P21. So if this is P21, let's find out what kind of pattern are we going to have here. So notice how these patterns go. P1, okay? So the ones with odd numbers, 1, 3, 5, those would be your arithmetic patterns. So let me actually just call these ones A. So this is A1, the arithmetic patterns term 1, A2, A3. Okay, so it means that P21, seeing that 21 is an odd number, it means that this is an arithmetic pattern. So this P21 would be A what? So if you try to find that out, notice what's going on here. Here, P1 is A1, P3 is A2, P5 is A3. Now the problem with this is this thing is not constant, because if you notice P5, the number that we have here, 5, it's 2 less than the one that you have here, 3. Okay, so P5 is A3. Now, for you to be able to rely on that and say, okay, so each term we're just going to have, if we have P whatever, we just take 2 terms less. Well, in order for you to rely on that, it also has to be consistent here. See, P3 is A2. That is just 1 term less. So we can't really rely on that. But what you can rely on, what we know is constant, is the G, okay? So P2 is G1, P4 is G2, P6 is G3. You will always notice that whatever number is here, the one that is going to be here would be half of that. So how about we find out, since this is the last term, P21, the previous term before this would have been P20. And because it's an even number, it is definitely a geometric pattern, because the geometric patterns are the ones with the even numbers P2, P4, P6. So if this is P20, this must mean that this one is G10, because it has to be half of that. That is the only one we can rely on. That keeps being constant. So we want to find out A, what this is. Okay, so to find out that, this is another thing we can look at. Looking at the first 2 terms, okay, these are both term 1s of the arithmetic and the geometric pattern. So notice the pattern is saying that we first have to have an arithmetic, then a geometric. That would be the first terms, okay, of the arithmetic and geometric. Term 1 of arithmetic and term 1 of geometric. Then we have A2 and G2. Term 2 of arithmetic, term 2 of geometric. Then A3 and G3. Term 3 of the arithmetic and term 3 of the geometric. So if we have G10, then before it we should have had A10, because that's the order it keeps going in. If we want the 10th term of the both patterns, we have to first start with the arithmetic pattern and then the geometric. That's what keep happening here. We have the arithmetic, then the geometric, and this is the 3rd term of both patterns. Then here we would have the arithmetic and the geometric, and this is the 10th term of both of these terms. So it means that in the geometric pattern, because the geometric one, P20 is the geometric pattern's 10th term, then it means that the last term here, this one, has to be A, since we have A10 here, this has to be A11. So this one, the arithmetic pattern, is ending at 11 terms, but the geometric pattern is ending at 10 terms. So we know where the terms end now. Okay, so the geometric one, I'll put that n is ending at 10 terms and the arithmetic n is ending at 11 terms. So we can go ahead and do that now. So n here of the geometric, it's ending at 10 terms, and then of the arithmetic, our n is going to be 11. So I'll just put that there as well. Okay, so now we can find the sum of this part. So remember, we're still going to add them together. Then it will form the P21 terms all up together. Okay, so I'm going to substitute this in. So we have S of 10 terms is equal to, we have 1 over 3 multiplied by 1 minus our constant ratios, 1 over 3 raised to the power of 10. And then close bracket over 1 minus, the bracket really doesn't matter, 1 over 1 over 3. Okay, so put that into your calculator and let's see what we get here. And on the calculator, we get 29,524 over 59,049. Weird number. Okay, now we got the sum of that. Now we need to find the sum of the arithmetic part. So with the arithmetic part, just also remember you also have two formulas that you can choose from. So you can either use this formula or you could use this formula. And honestly, I prefer to use this formula. It looks so much simple and we're going to use that. So with this formula, look at the things you need to have. You need to have n, which we do. We have what the value of n is. It's 11. There are 11 terms in the arithmetic pattern. Then we need to have a. Okay, so we can also find a. A is the first term in our arithmetic pattern. That is x. So we have a as x. And then we need to have L. Okay, so L, the last term in the arithmetic pattern. So let's look at what the last term will be. Remember that the terms ended at P21. And so our last term is A11. So we need to find the 11th term of this. That will not be difficult because look at the order of the way these terms are going. So in the A sequence, notice that A1 is X. In other words, 1X. So it's whatever the term number of that pattern is, of the arithmetic pattern, and then X. Then look at A2, it's 2X. So see the term number of that arithmetic pattern and then X. And then you see A3 is 3x. So it means that if this is A11, the value of this would be 11x. So 11x. Okay, so that would be the last term since they told us that it ends at P21. So we can just say that L is 11x. And now this makes this so much more easy to find. So we're going to go ahead and say we have S of 11 terms is equal to n over 2, which is 11 over 2, open bracket, and we have x as our a, plus L, which is 11x. And then we're going to have S of 11 terms is equal to the 11 over 2, x plus 11x, that's going to be 12x. Okay, so this is how you can look at this to simplify this. 12x as a fraction is really 12x over 1. So it's 12x and then it's put over 1. So these are being multiplied. So if the numerator is being multiplied with the numerator and denominator with the denominator, the thing about this is you can multiply the cross like this times this and find your number, and then the denominators multiply and find your number, and then simplify it further because there will be a common factor. Or you could have done this instead. Notice that across, when you look at them across, they can cancel since they're being multiplied. Okay, they're actually being multiplied. That's what brackets mean. So I'm going to cancel a 2 here. So I'm saying 2 divided by 2 is 1. And cancel a 2 here by saying 12 divided by 2, we're left with 6. So this is really just the numerators will multiply 11 times 6. That is 66. But remember we have an x. And then this is obviously a 1 left. 1 multiplied by 1 is just 1, but we don't have to put over 1. We can just leave it like this since the numerator already had a value. So it means S11 is 66x. That's what we get when we sum up 11 terms of the arithmetic pattern. Then the last thing we need to do is simply just put these together, because altogether, the sum of 10 terms of the geometric pattern and the sum of 11 terms of the arithmetic pattern make up the sum of the 21 terms of this PN pattern. So we're going to add them up together, and we know what it's finally equal to. It's equal to this. So we're taking the sum of the 10 terms and adding it to the sum of the 11 terms, and that will be equal to the total number here. The Pn is equal to 33,5, because that was what the sum of this pattern was equal to. So that's 33,5. Okay, so we have this number, and then plus the sum of 11 terms, which is the 66x, that is equal to 33.5. So this is a linear equation. We just have to solve for x. So to solve for x, to get to x, we're going to take this over. Okay, so take that over. We just have 66x is equal to whatever 33.5 minus this fraction is. Okay, so when we subtract, when we take that over, we get this really weird number. But I'm not going to write this. I'm just going to leave it like this, but I'm not going to round off. I'm saying 33,000. I know it keeps going. And then we need to divide both sides by 66 to solve for x. So I'm taking this answer and I'm dividing it by 66. So on your calculator, you can just say divide by 66. I have to say equal to first, divided by 66. And so as you can see, this gives us x is equal to 0,5 and then 0, but if you round it off, it's going to just give you 0,5, which 0,5 as a fraction is just a half. So that is our final answer. X is equal to a half. Okay, so that was the last question in 2.2.4. It just takes a lot of concentration and really just thinking carefully. Okay, and question 2 was worth 17 marks, and we move on to question 3. Okay, so now we're on question 3, and question 3 says, a quadratic sequence has the following properties. The second difference is 10. The first two terms are equal, i.e. term 1 is equal to term 2. And then term 1 plus term 2 plus term 3 is equal to 28. And so they want us to show that the general term of the sequence is this. So it means that they've given us enough information to be able to find the Tn formula. Okay, so let's just structure this info. Because they said the second difference is 10, let's go ahead and look at what this is going to look like. So remember, this is speaking about a quadratic sequence. The quadratic sequence looks like this. You first have your quadratic sequence on top. Then whatever these are, like you have term 1 here, term 2, term 3, term 4, and just keep going. Then to get the first differences, so let me just call that first differences. You're going to say term 2 minus term 1, and that will give you the first term of the first difference. Then term 3 minus term 2, that will give you the second term of the first difference. Term 4 minus term 3, third term of the first difference. Then that second difference that they're talking about, that second difference, you find that basically by saying T2 minus T1. That will give you that second difference, and it's constant, so I just call it D and D. Okay. Now, in this, we also know something else about this pattern and how it is. We also know that in these, you have to circle out the first terms in each pattern. In the quadratic pattern, the first difference and the constant difference. And we're going to equate all of these numbers, these first numbers, to the following. So it will have that 2a is equal to whatever that second difference is. Then for this one, we say 3a plus b is equal to whatever that is. And then, of course, a plus b plus c is equal to whatever that is. So from this, because we already know the second difference is 10, we can go ahead and say, okay, we know the second difference is already 10. So it means that 2a is equal to 10. And so we'll divide both sides by 2, and we find out that a is 5, just like they have here. Okay, so we have a. Okay, so to be able to find the rest of the things, let's go ahead and see what else they gave us. They said the first two terms are equal, term 1 and term 2. But right now, we don't know what the first two terms are. We don't know what T1 and T2 are. But we can actually create an equation for these two terms. So remember, the general form of a quadratic pattern is Tn is equal to an squared plus bn plus c. So it means that T1 is equal to, in place of n, I'm just going to substitute 1 Okay, so this is a bracket 1 all squared plus b bracket 1 plus c. And so we have t1 actually being equal to 1 squared is 1, 1 times a is a, and then b times 1 is b, and then we just have plus c. That's what t1 is. And because they also spoke about t2, we can also find t2. So term 2 is equal to, so in place of n, we're substituting 2. So that is a bracket 2 all squared plus b bracket 2 plus c. So term 2 is equal to 2 squared is 4. 4 times a is 4a. And then plus b times 2 is 2b plus c. This is what we have so long for t1 and t2. But we also know what the value of a is now. The value of a is 5. We found that because of that second difference they gave us. So we can put that into here. So it means that term 1 is now equal to 5 plus b plus c. And that term 2 would be equal to 4 multiplied by 5 plus 2b plus c. And so t2 is equal to, that will give you 20 plus 2b plus c. Okay, so apart from this, they also told us that term 1 and term 2 were equal. So if these two are equal, let's go ahead and equate term 1 with term 2, those two equations. So I'm saying, but they told us term 1 is equal to term 2. So we're going to say 5 plus b plus c is equal to, and then term 2 is the 20 plus 2b plus c. So this is what we have. We have this equation. Now, in this equation, if we decide to put the variables on one side and the numbers on one side, this is what's going to happen. Because this b is just a b and we have 2b here, I'm going to take this b over. So what we have here is we have the 2b minus b, and we have the plus c for that one. And I'm going to take this c over, and that gives you a minus c. So the numbers that we will have here, we just have a 5. And then here we had a 20. We can take it over. It becomes minus 20. 5 minus 20 is negative 15 is equal to 2b minus b. That's just b. And you can see that the c minus c would cancel. So that's one thing that we can already see from here. If you ever see positive c and positive c, you can just cancel it out on both sides. So you see, now we have b. So b is found. Okay, since we have b now, how about we just substitute this b into t1 and t2 so that we can also just have that in a more simplified form. So term 1 is equal to 5 plus, and then you have the b. But because b is negative 15, I'll just say 5 minus 15, and then we have plus c. Okay, so this is going to be term 1 is equal to 5 minus 15, negative 10 plus c. That's what term 1 is. And then term 2 is going to be, so term 2 is this 20 plus 2b. When in place of b, we're going to put in negative 15 and then plus c. Okay, so this is going to give us t2 being equal to 20, 2 times negative 15, that is negative 30. And then we have plus c. So term 2 is equal to 20 minus 30, that is negative 10, plus c. Notice they're the exact same thing. And that makes sense because they said that t1 was equal to t2. Okay, so the whole point of this is we need to find c. Just looking at these two, if you equate them, unfortunately, they're not going to help you find c because they're the exact same thing. I know they did say that t1 is equal to t2, but even if you did this, it will not find c. You see, it's exactly the same thing because they have the same term value. And that's probably why they gave us that third information. The third information was this, that t1 plus t2 plus t3 is equal to 28. So let's use that instead. We know that t1 plus t2 plus t3 is equal to 28. We have an equation for t1, we have one for t2, we don't have one for t3. So we can start off by finding an equation for term 3, just like we did with term 1 as well. So we're taking the general form of the quadratic sequences formula, and we're going to substitute in place of that, in place of n, we're going to substitute 3. So we're going to say term 3 is equal to a bracket 3 all squared plus b bracket 3 plus c. And so term 3 is going to be equal to, that's going to give you 9 times a, which is 9a. And then that's going to give you 3b, and that's going to give you plus c. But we know what A is, and we also know what B is. So we can just substitute in place of A and B. The value of A is 5. The value of B is negative 15. So it means that we have T3 being equal to 9. In place of A, we have 5 plus 3. In place of B, we have negative 15 plus C. Okay, so T3 is equal to 9 times 5, that's 45. And then we have negative 45 as well, plus C. Okay, so in this case, term 3 is equal to 45 minus 45, which will cancel, and then you're just left with C. Okay, so term 3 is C. So now let's go ahead and use this equation they gave us, that third equation, or the third information. They said term 1 plus term 2 plus term 3 should be equal to 28. Term 1, the value of term 1 is this negative 10 plus C. So negative 10 plus C, then we're adding that to plus, and we have negative 10 plus C. But because we have a negative 10 there, I'm not going to say plus. Minus 10 plus C as well. Just see it like this. It's kind of because even if you had to say plus and you put brackets because you're adding by something that has more than one term, if you multiply it in, you would still have a negative 10, you'd still have a positive C. So the plus doesn't really affect it. You only put brackets when you're subtracting. So that's all we have here. Then plus term 3. Term 3 is just C. So plus C is equal to 28. Okay, so we have negative 10 minus 10, which will give us a negative 20. Then we also have a positive C plus C, and then plus another C, which will give us plus 3C. And that is equal to 28. So let's just make C the subject. So 3C is equal to, we have 28, and we're going to take this negative 20 over and becomes a positive 20. So 3C is equal to 28 plus 20, which is 48. And if we say 48 and then divide both sides by 3, so 48 divided by 3, that is 16. So C is equal to 16. And there we go. We got A, B, and C. Okay, and there C is also positive 16. So that is the general formula. So you can go ahead and just simplify this and just write, therefore, Tn is equal to 5n squared and then plus Bn, but B is negative 15. So we have minus 15n and then plus 16. So there we go. Okay, so it's just the thing where you had to use everything they gave you, and that is worth 6 marks. Okay, moving on to the next question. Then 3.2 says, is 216 a term in this sequence? Justify your answer with the necessary calculations. So is 216 one of the terms in the sequence? So the terms in the sequence would be obviously the quadratic sequence. So is it one of these terms that are in the sequence? So to find out if 216 is a term, okay, is one of the term values in the sequence, all we'd have to do is take the general formula that we have. Because we are trying to find out if this is a real term in this sequence, we need to find out which term number it belongs to. So in order to find the term number is n. We need to solve for n. So we're going to take 216 and put it in place of Tn, because we're saying T what, okay, is equal to 216. And that T what really stands for Tn. So when we find n, we can say T whatever that is equal to 216. So in place of Tn, we're going to put 216. Okay, so it's going to be 216 is equal to, and we have 5n squared minus 15n plus 16. And let's go ahead and simplify this. So because n squared, its coefficient is positive, I'm just going to go ahead and take this over. So we have 0 is equal to 5n squared minus 15n, and then we have plus 16 minus 216. And so that is probably negative 200. So if you have 16 minus 216, we get negative 200. So that gives you a minus 200 when we take that over. Okay, now this is a quadratic equation that we have, because you see n squared, n, and a constant. This is a quadratic equation, and it's a trinomial. So we need to solve for n. If you look through all these terms, you will notice that we have a common factor. 5 can go into all these numbers. So we can just go ahead and divide both sides of the equation by 5. 0 divided by 5 is 0, and then is equal to n squared. And then negative 15 divided by 5, that's negative 3n. And then negative 200 divided by 5, that is going to give us negative 40. Okay, so this is what we have now, and we have to factorize this. So open up two brackets, and we're saying what multiplied by what gives you n squared. That's n multiplied by n. What multiplied by what can give us 40, but will also help to give us a 3. So I think the factors 8 and 5 would work, because 8 times 5 is 40. So, but if we make the 8 negative, so negative 8 and positive 5. Because if you say negative 8 plus 5, you're going to get a negative 3 in the middle. Okay, so these are our factors. So it means that n is either equal to, we're going to take the negative 8 over the equal to sign. So it's either equal to 8 or n is equal to a negative 5. But remember, we are working with sequences. Sequences cannot have negative term values. And really the reason why is because they're speaking about positions. This sequences could be their patterns. So it could be a situation like somebody keeps running every day and they keep running 10 kilometers more every day, something like that. So the n really stands for, it could stand for something like the days. So on day 1, this person ran this amount. Day 2, the person ran that amount. We cannot have anything like day negative 5. Okay, that's the reason why we cannot have the term numbers be negative, because they're speaking about positions. So it would mean that I'll cancel that one, and it means that it's actually T8, term 8, that has a value of 216. Okay, so to conclude, is this a term in the sequence? Yes, then you can say 216 is a term in the sequence, and of course, all this calculation would be your reason. Okay, so that is this question. I think that's the last question for question 3. Yes, okay, so that is the last question for question 3. So we move on to question 4. Okay, so now we're on question 4, and 4.1 says, given the function p of x is equal to 1 over 3 raised to the power of x, 4.1.1, is p an increasing or decreasing function? Okay, so to find out whether it's an increasing or decreasing function, this is all you can do. If the function is going to increase, how about we first find out if we substitute 1 in place of x? So it's kind of like looking at it as a graph. If we have 1 here and 2 here, let's just find out whether it's going to increase or decrease. So substitute 1. So I'm saying p of 1, which is going to be 1 over 3 all raised to the power of 1. And that will just give us 1 over 3. Okay, so let's say this is our y-axis and we have 1 here. So if this is 1, when we substitute 1, we get the answer 1 over 3. Okay, so 1 and 1 over 3, maybe just here, like a third way through. Okay, then try p of 2. So substitute x value of 2 into this. So I'm going to see whether it increases or decreases. Then we can just say 1 over 3 raised to the power of 2, and this will be equal to 1 over 9. So you see, 1 over 9 is smaller than 1 over 3. You can even check the decimals on the calculator. So it means that from at 2, you have 2 and 1 over 9, which is much smaller than that. So as you can see, from this point to the next point, it decreased. Okay, we're talking about the y values. The y values are decreasing. So this graph is not an increasing function, it's a decreasing function. So that's something you could have looked at. Just see whether it increased or decreased, and that actually decreased. Okay, so you can conclude p is a decreasing function. Okay, so moving on to the next question. As you can see, that's for 1 mark. They really just wanted to see the answer. There is a way of doing it, but then that takes quite long, where you have to think about the value of a and b. You can do that as well, but it does take quite long. You could have just done that. It's easier. So question 4.1.2 says, determine p negative 1, the inverse of p in the form of y is equal to. Okay, so we have to just determine the inverse of this equation in this form. So I'm going to put this first as y is equal to, not p of x. So y is equal to 1 over 3 raised to the power of x. To find the inverse of a function, first step is to swap the x and the y. So this is why I'm going to turn it into x is equal to 1 over 3 raised to the power of, this was x, I'm going to turn it into y. Then the second step is to just make y the subject. So if we make y the subject, y is on the exponent. The only way to make an exponent the subject is to use log. So we're going to say y is equal to, and now we have it's the log, and the base is going to be 1 over 3, just like it is here. This is the base carrying the exponent, so it's still the base. And then here we have the x. So there we go. Y, we have log of x with a base of 1 over 3. And that is, of course, for 2 marks. So that's 4.1.2 done. Moving on to the next question. Okay, 4.1.3 says, write down the domain of the inverse of P. Okay, so there's something you need to know about the range at the domain of an original graph and the inverse. So I'm going to put the original, and over here we speak about the inverse. So in this case, the original was that P of x, so it was equal to 1 over 3 raised to the power of x. And the inverse is the log graph. Y is equal to log, we have a base of 1 over 3 and x. And then over here, I'm going to speak about the domain of the graph and the range. So the thing about the domain and range is the original graph, whatever the original graph's domain is, that will become the range of the inverse. And whatever the range of the original graph is, that will become the domain of the inverse. So notice that they asked us to find the domain of the inverse. So the domain of the inverse is actually the range of the original. So all this means is if we can find this one, we will know exactly what the domain of the inverse graph is. So let's go ahead and find the range of the original graph. Okay, so if this is the original graph, P of x is equal to 1 over 3 to the power of x, then also notice what the value of a and b is. Because P of x is equal to 1 over 3 raised to the power of x, then if I'm putting it in terms of a and b, so I'm saying y is equal to, the way the graph is supposed to be written, the original form of an exponential graph is a bracket b to the power of x minus p plus q. So if a is greater than 0, it would just mean that your graph is going to lie above the asymptote. So wherever this asymptote is, so let's just say we have an asymptote, the graph is going to lie above the asymptote. Now we also know that this graph is decreasing, and this is an exponential function. So the graph is actually going to look like this. See, it is decreasing, moving from left to right, it is moving down. So if the graph looks like this, what is the range of this graph? Okay, so looking at the y value, so let's say this is your y-axis over here. Looking at the y values of the graph, you have an asymptote. You always have to focus on what the asymptote is. The equation of the asymptote is y is equal to q, whatever the q value is. Now, as you can see, we're supposed to have plus something or minus something, but because we don't have anything, it means the value of q is actually 0. So our q value is 0. So if that is the case, then look at the range of the graph. The range is all the possible y values that the graph can have. Notice the graph will not have any y values down here. It only has y values here. So you're going to have to find out where is your asymptote. Your asymptote is at y is equal to 0 because that's the value of q. And then notice that only from numbers that go above 0 do you have y values. Because look, this point over here, that's its y value. This point over here, that's its y value. And that's its y. It keeps having y values that are only greater than 0, but not equal to 0 because at 0 there's an asymptote. So here, the range of this graph is that y is greater than 0. Okay, so now that we found the range of the graph, we can find the domain of the inverse. If the range is y is greater than 0, then the domain of the inverse, remember its domain, meaning it's not speaking about y values, it's speaking about all the possible x values. So that means that the domain is x is greater than 0. That's how we get that answer. Okay, so that is, I just gave that explanation just so that it can make sense. You would really just have to say x is greater than 0. Okay, so that's what I meant by this paper is going to definitely be longer than 3 hours because I'm just going to be explaining certain things. And then question 4.1.4 says, write down the equation of the asymptote of p of x minus 5. Okay, so to understand what p of x minus 5 means, so we're taking the graph of p and we're moving it down by 5 units, okay? That's why it's saying the y, p of x stands for y. So you can think about it like this. If this graph, its asymptote was originally here, y is equal to 0. But now we are taking this graph and we are shifting it down by 5 units. So if this graph goes down by 5 units, the new asymptote, every y value is also going to move down by 5 units. So if this was y is equal to 0, it will move down by 5 units, meaning now it's going to be that 0 minus 5 because it's moving down. The new asymptote is going to be y is equal to negative 5. Your graph is going to be down here and it's going to have an asymptote at negative 5, at y is equal to negative 5. Okay, so that is a graphical way of looking at it. If you didn't look at it as that, you could have just done that with the equation. So the equation of this graph was 1 over 3 all to the power of x, right? That was p of x. That's what that stood for. So you'd have said 1 over 3 to the power of x. That's your p of x. Then you'd have said minus 5. And if this is the new equation that we have, the equation of the asymptote is always y is equal to whatever number is here, whatever is your q value. And so that will be negative 5. So that is the equation way of doing that. Okay, so that's the equation of your asymptote, your horizontal asymptote of this graph. Then moving on to 4.2, we are given f of x is equal to 4 over x minus 1 plus 2. 4.2.1 says, write down the equations of the asymptotes of f. So the equations of both asymptotes. So meaning the vertical and the horizontal asymptote. The vertical asymptote will always be x is equal to whatever the value of p is. And the horizontal asymptote is always going to be y is equal to whatever the value of q is. Your equation, the general equation is y is equal to a over x minus p plus q. So let's find the value of p and q so we can just put it there. So p is equal to, notice here we have a minus p. But here we have a minus 1. So think about it like this. We have p and we have 1 over there because the minus is really the minus here as well. We have x minus 1, x minus p. So it just means that p is equal to 1. That's the p value. P is equal to 1 and it means that q is equal to whatever number is here plus q, which is 2. So that's something you should always know about this. The value of p, even if you have x minus 1 here, the value of p will actually be positive 1. If it was something like x plus 2 here, the value of p would be negative 2. It always changes signs when it has to do with the p, but not the q. So this would just mean that the vertical asymptote would be x is equal to, the p value is 1, and the horizontal asymptote would be y is equal to, that q value is 2. Okay, moving on to the next question. 4.2.2 says calculate the x-intercept of f. So since f of x is equal to 4 over x minus 1 plus 2, so we just have to find the x-intercept. The x-intercept is where our y value is equal to 0. So we're just going to make y equal to 0. F of x stands for y, so we're saying 0 is equal to 4 over x minus 1 plus 2. Then we can take the 2 over, so we have a negative 2 is equal to 4 over x minus 1. Because we have a number here, a fraction here, and equal to in the middle, we can cross multiply. So we're going to just take the negative 2 and put it over 1. Then you cross multiply. It's the negative 2 being multiplied by the x minus 1. And it just really gives you this so long. I'm just saying it's a negative 2 that has to multiply into the x and the minus 1. And then it's equal to the 1 multiplied by 4, which gives you a 4. Then we need to get into the x. So we can just go ahead and divide both sides by negative 2. And so we have here negative 2 is equal to then we have x minus 1. To make x the subject, take negative 1 over. Negative 1 becomes a positive 1, and we still have a minus 2 is equal to x. So therefore, x is equal to 1 minus 2, negative 1. So the x-intercept, they specifically just said the x-intercept of f. That is the x-intercept. So because they're already asking us about x-intercepts, they spoke about the asymptotes, you can already expect they will ask you to draw the graph. So 4.2.3 says, sketch the graph of f, label all asymptotes, and indicate the intercepts with the axes. Remember, they want the asymptotes. We have those already. But they also want all the intercepts with the axes. So this would be your x-intercept and your y-intercept as well. Those would be that. So we already have the x-intercept. We just don't have the y-intercept. So we have to find that first. So to find the y-intercept, here's the function. To find the y-intercept, you need to make x equal to 0. Okay, so we're going to say f of, and in place of x, we're saying 0 is equal to 4 over, there's an x again, 0 minus 1 plus 2. So this is going to be equal to, so we have 4 over 0 minus 1. 0 minus 1 is negative 1. So 4 divided by negative 1 is negative 4 plus 2. And so negative 4 plus 2, that's going to give you a negative 2. So this is your y-intercept. So we can lay down all the points that we have. We only have x-intercept, y-intercept, and our asymptotes. So let's go ahead and put down the x-intercept. If this was the x-intercept, it means as a coordinate, it's going to be negative 1, and the y value is 0. See, that's why we make y equal to 0. So it's negative 1 and 0. And then the y-intercept, the x value, we made that 0, and the y value is negative 2. And then our asymptotes are also important. So our asymptote is x is equal to 1 and y is equal to 2. So with all of this, we can actually draw down the graph. Okay, so this is the Cartesian plane that I have. This is your x-axis, and that is the y-axis. So first, start with putting down your asymptotes, because this will really just help the shape of the graph so that you know what line you should not go beyond. So the vertical asymptote is x is equal to 1. Okay, so that is a vertical line, a standing line. So it's x is equal to 1 because it is a line that passes the x-axis at the point where x is equal to 1. Okay, so this is the vertical asymptote. So it also goes on to infinity, and you should always just write the equation of it. So that is the x is equal to 1. And then your horizontal asymptote is y is equal to 2. Okay, it's a horizontal line, so it will pass the y-axis and specifically at that point 2. So it is just a horizontal line that looks like this. And you always need to write its equation. That is y is equal to 2. Okay, now that those are down, we can put the intercepts now. The first point that we have is the negative 1 and 0. So negative 1 and 0, that's our x-intercept, negative 1 and 0. So here's that point. You can write the coordinates if you want, but we can also see that it's intersecting at that point. So we know it is an x-intercept. Then the y-intercept is 0 and negative 2. So 0 on the x-axis and negative 2 on the y. So there we go. So that's 0, negative 2, that is negative 1 and 0. Okay, so now another thing you also should look at is the way this graph is going to look. Notice that the value of a, okay, is 4. So it's a positive number. When a is positive, it means that your graph is going to lie in the first and the third quadrant. So it's going to lie here, the first quadrant, and in the third quadrant. So you can already see these points are going to be the ones here in the third quadrant. So the graph is always going to do this. It's going to come from the asymptote, being very close to the asymptote. It's going to move here, hit negative 1 and 0, hit 0 and negative 2, and then move closer and closer to this vertical asymptote, but it will never touch it. So it's going to look like this. And of course, we'll have the arrows here. So this is just the one that is in the third quadrant. We still also need one in the first quadrant. So you can just draw it. If you like, you can substitute a point in here. Okay, then you can just draw the other wing as well. It's also just going to do something like this and move like that. And so it's going to look like that. They didn't really say anything about drawing another point because they really just want you to label the asymptotes and indicate the intercepts with the axes. And it's for 4 marks. And since it was called f of x, we can just name the graph f. Okay, so that's it for the sketching of the graph. Then the next question, 4.2.4 says, use your graphs to determine the values of x for which 4 over x minus 1 is greater or equal to negative 2. So with this question, just notice that this looks very similar to the graph that we have, the equation that we have. The only difference is we have a plus 2 here. And that's just because you have to just take this, negative 2 over. So when you do that, you have 4 over x minus 1 plus 2 is greater or equal to 0. This is actually what we need to solve for. We need to find the values of x for which the graph that we have is greater or equal to 0. And when they say that, they're referring to the y values of the graph. So where are the y values of this graph greater or equal to 0? Okay, so looking at the graph, here is your y values, okay? That's your y-axis. So we're looking for only the places where the y values are either equal to 0 or greater than 0. So we'll only be looking at this part, okay? So everything that has y values within here. And so you see the graph here, that's the y value to greater than 0, keeps having values greater than 0 all through. And then at 2 itself, it doesn't have a y value there because there's an asymptote. And as you can see here, that has a y value greater than 0. So we're only going to be looking at this top part of the graph. Okay, nothing on the bottom because all of these have y values less than 0. So what you can do now is highlight the parts of the graph that are on top in the first and the second quadrant. That will be everything here and everything here, but stopping at negative 1. And now that we have them highlighted, we can find out which values of x belong to these highlighted parts of the graph. And I'm going to start from the left because it's easier to read numbers from the left to the right. So from the left hand side, you see that this keeps going on. It's going to keep getting closer and closer to this asymptote infinitely. So here it has an x value of here and here. Keeps having all these x values. But when did they start? Where was the y value of this graph equal to 0 in the first place? That was here at negative 1. It was equal to 0 at negative 1. And then every place that is here, all of these x values that I've marked. So these places, when you compare them to negative 1, they are values that are less than negative 1. So this happened when x was less than or equal to negative 1. Remember, we're including negative 1 because they said that this needs to be either greater or equal to 0. The y values need to be greater or equal to 0. And at negative 1, the y value is equal to 0. So negative 1 is an included point. So that would be the solution for that part of the graph, that highlighted part. Then we have to do the same to this part of the graph. I'm also going to read it from the left to the right. It's easier like that. So if you look at this graph, it's coming from a place that is very close to this asymptote. And that asymptote itself is 1. So it means after 1, okay, something like 1.01 or something like that, you're going to have a y value in this graph that is greater than 0. So we can mark all of these parts of the graph. Here's the x value of this, and here's the x value of that. I'm only marking the x values of the highlighted parts of the graph because those highlighted parts of the graph have y values that are either greater or equal to 0. So you see these parts of the graphs, look at their x values. So the x values belonging to all these parts of the graphs is all of these values here. And these are values that are greater than 1. Okay, and I'm starting at 1. The reason I'm starting at 1 is I can't just start at 2. At 1.1, for example, we have a y value on this graph. And that y value is greater than 0. Okay, the only place there isn't a y value on this graph is here where x is equal to 1. We don't have that. So this is where x is just greater than 1. I can't say greater or equal to 1 because there is no value here. We don't have an x value here. So all of these values that are greater than 1. So those would be our solutions, where x is less than or equal to negative 1 or where x is greater than 1. Okay, and we don't have to write them together because as you can see, they're really pointing towards the opposite directions. These ones are going that way to the left, and these solutions are going to the right. Okay, so that's the solution, and moving on to the next question. Okay, so question 4.2.5 says, determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. Okay, so since they're asking you for the axis of symmetry that has a negative gradient, that equation looks like this. So we have two axes of symmetry in this hyperbola. One has a positive gradient, so it's an increasing function moving upwards like that. And the equation of that one is y is equal to x minus p plus q. And this is quite easy to remember because of the general form of the hyperbola, which is y is equal to a over x minus p plus q. So you see that x minus p plus q repeating itself here again. Now, the only reason I'm showing you the one with a positive gradient is because this one can help you to formulate the formula for the one with a negative gradient. And that one looks like this. So it is a decreasing function, and both of them, of course, they would pass this point where your asymptotes intersect. This one with a negative gradient is what they asked us for. That equation looks like this. Y is equal to, now in front of the x minus p, we put a negative. So put a bracket x minus p, and then we have the plus q again at the end. So this negative actually multiplies into the x and the minus p. So you have a negative x and then plus p plus q. So that's the equation of the one with a negative gradient. But then they also say, so just keep that in mind, the general equation of a graph with a negative gradient is y is equal to negative x plus p plus q. But they told us that we have to determine this equation for the graph f of x minus 2. So we need to see, what does this do to the graph? When you say x minus 2, this is only going to affect the x values of your graph. So since our graph was a is equal to 4 over x minus 1 plus 2, it's only going to affect this part of the graph. We're going to have that f of, because this was f of x, so that f of x minus 2 is going to be 4 over, we have an x, then you're going to say minus 2, okay? Then of course we have this minus 1, then the plus 2. So the new equation would be 4 over x minus 3 plus 2. And so how does this affect this? Well, it affects your value of p, but not really your value of q. So now the new value of p here is going to be, since we have minus 3 here, the value of p is positive 3. And the 2, it didn't affect that. So q is still equal to 2. So that's what this is supposed to help you with. So we're going to apply that into this equation. So our new equation of the axis of symmetry with a negative gradient is y is equal to negative x plus p, which is 3, plus q, which is 2. So that is y is equal to negative x plus 5. That is the equation of your axis of symmetry with a negative gradient if we have f of x minus 2. And that is the last question in question 4. So we just move on now to question 5. Okay, so question 5 says the graphs of the functions f of x is equal to negative x plus 3 all squared plus 4 and g of x is equal to x plus 5 are drawn below. The graphs intersect at A and B. Okay, then the first question is for us to write down the coordinates of the turning point of f. Okay, I'm going to get rid of the calculator for now because I don't really think it's helpful right now and I really just need this space. Okay, so to find the coordinates of the turning point, just remember that when the parabola is put in this form, this is turning point form, which is a bracket x minus p all squared plus q. And the turning points will basically be your p value and your q value. Remember that if you have an x plus 3 here, so plus something, the p value is actually the negative of whatever number is here. So your p value, the first x coordinate would be negative 3, and then the y coordinate would be the q, which just stays the same. So whatever is here, that will be the y coordinate, and that is 4. So we have and positive 4. So that would be the coordinates, and you see it's just for 2 marks. Then the next question, write down the range of f. So to find the range of f, think about the fact that we know the turning point now. The turning point of this graph is -3 and 4. So if this is -3 and 4, remember the range is all the possible y values that this graph, this parabola can have. So if you look on the top here, you notice there is no parabola up here, meaning the parabola will not have y values on any part of here. Okay, there's no y values here, but it starts having a y value at this turning point first. And at this turning point, the y value that it has is 4. Then you see that, look at the point here and look at this point over here. Look at the y value. It's a y value that is below 4. And then another point on the graph, these 2 points, it's a y value that is also below 4. And this will keep happening on the parabola. It will keep having y values that are below 4. So it means that your range is that y needs to be less than or equal to 4. So we have to also say equal to 4 because 4 is also the y value of the turning point of this graph, meaning this is also a point on this graph. 4 is also a y value on this parabola. So that is our range. The range is y is less than or equal to 4. So you just have to see whether it's concave up or concave down to see what the range is going to be. Okay, then the next question is, you need to show that the x coordinates of A and B are -5 and -2 respectively. Okay, so A and B. So if we're looking at A and B, you see that these are points of intersection of these two graphs. So to find the points of intersection of two graphs, you just have to make the equations equal to each other. So we're going to make f of x equal to g of x. And f of x was negative bracket x plus 3 all squared plus 4, which is equal to the g of x graph, which is x plus 5. So, which is equal to x plus 5. Now we just have to solve for x. So when solving for x, I'll start with this part. So we have the negative, and then let's simplify what's inside this bracket. You square the x, gives you x squared. Then you square the last term, positive 3 gives you positive 9. Then you say the x multiplied by the positive 3, which will give you 3x. Then you take that 3x and you multiply it by 2, which will give you a positive 6x. That's how we get the middle term. Then we have plus 4, and we also have these. I can just take them over so long. Minus x minus 5 equals to 0. Then we'll multiply in this negative into these 3 terms in the bracket. And so we get a negative x squared minus 6x minus 9 and then plus 4. Okay, so 4 and negative 5 can go together. So positive 4 minus 5, that will give you negative 1. And then we have minus x is equal to 0. Then we still have negative x squared, and then the negative 6x and the negative x can go together, and that will give us negative 7x. Then, of course, the negative 9 and the negative 1 will simplify to negative 10 is equal to 0. So when you're at this point, you can take everything over, or you could just go ahead and divide both sides by negative 1 so that we can make the coefficient of x squared positive. Then, because it's easier to factorize like that, then we're going to have x squared and then positive 7x and positive 10 is equal to 0. So let's factorize this. Open 2 brackets equal to 0. What times what gives you x squared? X times x. What times what gives you positive 10? And remember, everything is positive. Okay, but you need to get a positive 7 in the middle. So that can be positive 2 and positive 5. So if we're solving for x, it means that x is either equal to negative 2 or x is equal to negative 5. Okay, so those are the two solutions for x that we have. And so that would be A and B. But because they say respectfully, and so they want you to know exactly which one belongs to what. So I'm just going to also conclude which one belongs to A and which one belongs to B. So on your graph, you see that A is more to the left than B. So this would be the negative 5 and that would be the negative 2. Okay, so here I'll just conclude it by saying that x of the coordinate of A is the negative 5 and x of the coordinate of B is the negative 2. Okay, so that is 5.3. Then moving on to the next question. The next question says, hence determine the values of c for which the equation negative x plus c plus 3 all squared plus 4 is equal to x plus c plus 5. Okay, so something you need to notice here is this is the exact equation of f of x. We're just adding a plus c this time. And this is the equation of g of x, we're just adding a plus c. Okay, so when we add a plus c inside, okay, to the x, now you're not moving this parabola up or down. You're actually moving it left or right because the c is affecting the x. So depending on what c is, it will be moving this graph left or right. Now in the straight line, what it's actually doing is, regardless of what you put here, it's actually going to still move the graph up or down, because think about it, you had x plus 5. And even if I just decided to say, okay, x, and then in place of c, I say plus 1, then I have plus 5. Then if you simplify this, because there's a plus here, it's just x plus 1 plus 5, which is just x plus 6. And you see that will just move this graph that was x plus 5, it's just moving it 1 unit up. So what I mean by this c is that with the straight line graph, it's really moving the straight line graph either up or down, depending on what c is. But with the parabola, it's moving the parabola either left or right, because it's affecting the x. Okay, but look at the full question. The question is just saying, hence determine the values of c for which the equation this has one negative and one positive root. So we need to have one negative root and one positive root. You see, the minute they start to speak about roots like this in detail, so if they were saying something like determine the values of c or k for which the roots will be non-real or real or even unequal, you see, that case you would deal with delta, because delta can affect the nature of the roots, but delta does not manipulate whether the roots will be negative and positive. You do that using the graph. Okay, so another thing that you should take note of, they are equating these two equations, the equation of the parabola and the equation of the straight line. And they're asking about the roots. They want the roots to be one negative and one positive. So it just really means that we're speaking about these roots that we're referring to. It's not actually just x-intercepts, well, they are, but in our graph, they're really just the x coordinates of our points of intersection between these two graphs. That's why we're equating these graphs. Okay, so that really refers to A and B, the x coordinates of A and B. That's what they mean by the roots. So let's see what the roots, okay, of this equation being equated currently is. The current roots that we have is, we have a negative root and a negative root. Okay, those are the x coordinates of the points of intersection between the two graphs. We want a situation where it's a negative and then a positive root. Remember that the equation said that by the parabola we have a plus c, meaning you have to move this graph left or right. It's not speaking about a plus c on the outside. If it did that, then you'd be moving the graph up or down. Okay, so we have to think about how do we move these two graphs together in a way that they're going to have one negative root and one positive root. Okay, not just negative and negative. So let me draw another one of the parabola and the straight line as well, so that we can move them and see what happens to them. Okay, so remember that these two graphs are going to move by the same amount. When we are manipulating the parabola is either going to move to the left or to the right because of that plus c that we had after the x. But you also see that that plus c really moves the straight line either up or down. But this doesn't really matter, because the thing about a straight line is that it extends to infinity, just like also a parabola. And you can see it like this. Let me make another copy of this. So if you see this straight line, so I made a copy of it. Let's say it was here, right? And because of that plus c, let's say we're moving it down. Maybe it causes the graph to move down. I just want you to see what happens. If this graph shifts down, right? You can see it visibly going down right now. But if you looked at it as a graph like this, it doesn't actually look like it went down in a way. Like, yes, because of I moved it, you actually saw it going down. But if you look at this, look at the fact that here it intersected the x-axis at -5. But here, look at where it's intersecting the x-axis. It kind of looks like it's just moving to the right. That's what it looks like. Okay, so I just want you to see that it is actually moving down, but it will look like it's moving to the right just because it's a straight line. Okay, so let's focus on the parabola first. How do we move this parabola so that these two graphs, when they will both move, they will both have a negative and then a positive root as well? So if you look at the parabola and you look at how you should move this graph, if you move it to the left, you see the problem with this is we're not going to get this type of roots that we want. The root is still going to be, we're looking for the point of intersection of the parabola and the straight lines. You see, it's a negative value and it's also another negative value. That's not what we want. And if you keep moving it to the left, that's what you're going to keep seeing. So instead of moving it to the left, let's move it to the right. Okay, so let's talk about what right movements do or how to move things to the right using a parabola. If this is the equation of the parabola and you want to move it to the right, you're going to first of all put whatever number, the amount of units that you want to move it to the right. Okay, it's going to be affecting the x. We're going to put it next to the x. Now, when you're moving something to the right on a parabola, you don't say plus. For example, if I wanted to move it like 1 unit to the right, I will not say +1. You will say -1. You're going to have to put a -1 in here for it to actually move to the right. Now you see this -1, we're moving it by the same amount of units on the straight line as well. That's why we have that +c in both equations. So if we're moving it 1 unit to the right, look what that's going to cause this one to do. If you put that -1 next to your x, -1, then you have the +5. What it's going to do to the straight line graph is it's going to cause the straight line graph to move 1 unit down. But this won't really make too much of a difference. So you see it as this is moving 1 unit to the right, and this one ends up moving 1 unit down. And this is what I mean by it's not going to cause that much of a difference, because you see it's still going to intersect at the exact same places. Not at the exact same number, but they're both still going to intersect at the x-axis first, and then they're going to intersect here again. Okay, so 1 unit will definitely not just be enough to give it a negative and a positive root. So you see we still have a negative and a negative root. So how many units to the right do we have to move it? Okay, this is how we can look at it. When it is sitting here, focus on the point B. So B is -2. How about we move this graph, the parabola and the straight line graph? Let's move the parabola first of all 2 units to the right. So if this is -2 and we count 1, 2, we will be at the origin. So it means this point of intersection will now happen here on the y-axis. So the parabola will move like this to the right until it cuts the y-axis, something like that. Okay, and what the straight line would do is, because this one is moving to the right, the straight line, it will cause the straight line to move down, like I explained here. It causes the straight line to move down, and you see, look at them intersecting again. It intersects here on the y-axis, and it's still going to intersect at the x-axis as well. So let's see, do we have the type of roots they're asking for? Well, we have a negative root, but now one of our roots is not positive, it's just 0. So we would need to move this parabola a little bit more. So it means that we need to move the parabola at least just more than 2 units to the right. If it is more than 2 units to the right, it will pass this y-axis, it will pass this origin, and it will have a positive root. Okay, that's the whole point of that. So let's put that point down. So we need to move it more than 2 units to the right. Okay, but how far? We can't just move it more than 2 units, because if we move it more than 2 units, it's just going to keep moving like that. You just keep moving. Where should we stop? How do we know where to stop? Okay, so this is how you know where you need to stop moving it. Look at the fact that this here, this point of intersection or this root was -5. Okay, if you move this graph, so it's a negative root and we want the roots on this side to stay negative because the one on this side will be positive when we move it a bit more than 2 units to the right. So that it can continue to stay negative, as long as it does not move anything more than 5 units. You see, we're at -5. If you move 1, 2, 3, 4, 5, that root will now be at the origin. As long as it doesn't move anything more than 5 units to the right, we're going to be okay with this. Okay, because this is what's going to happen if you move them more than 5 units to the right. So if it was here and you move it, let's just say even 5 units. If you move it 5 units to the right, this is what's going to happen. You see, now look where it's sitting. Okay, yes, we will have a positive root here, but then we'll have a root of 0. And then if you move it anything more than 5 units, you're going to end up with a positive root, and the roots that you're going to have here is also going to be positive. But we're looking for one negative and one positive root. Okay, so that is the amount we should not move it past. You need to move it more than 2 units to the right, but not more than 5 units, not more than 5 units. Okay, so now how do we interpret this with what they gave us? How do we tell them what the value of C needs to be given this description? So let me rewrite what we had as f of x in that equation. Remember, we had f of x and g of x being equated, but we had negative bracket x plus c and then the plus 3 all squared. And they said it was equal to the x plus c, and then we had the plus 5. So remember that now we know that this c, it has to move to the right. And remember, when things have to move to the right, looking at the equation, you do not say plus to make it move to the right. You say minus. So this c is now going to be negative. We need to move it to the right, meaning it's going to be a negative value so that it can be a right shift. So I'm treating this negative c as if it is the right shift. I'm saying that this right shift, this negative c, it needs to move more than 2 units to the right because it's already moving to the right by saying negative c. It needs to be greater than 2, but less than 5. Okay. Then now we just have to solve for c. So to solve for c, we see that this is negative. So you have to divide by a negative. If you divide both sides by -1, it will make the c positive. So now the c is positive. But you need to remember that in inequalities, when you divide or multiply by a negative, it will cause the signs to change. So 2 divided by -1, that's -2. But this sign is going to change direction. It's going to look like that now. And then 5 divided by -1, it is -5, and this sign also changes direction. So if you read what this is saying, because this is not put in the proper way, we're supposed to have the c in the middle, the smaller number here, which would be the -5, and then the bigger number here, which would be the -2. So if you see what this is saying, compare the c to the -5. The inequality, the mouth needs to face the c, so we draw it facing the c. When you compare the c to the -2, the mouth needs to face the -2. So it's really saying that c needs to be greater than -5, but less than -2. And that will be our answer. So I'll put that calculation and this as well in my answer. And there we go. So that is the answer. C just needs to be greater than -5, but less than -2, so that we will have one negative and one positive root. So that, of course, will move these graphs in a way that it's going to basically move this one past this point, moving it more than -2 units to the right, and moving this one more than 2 units down because it will cause that one to shift down. And so you see the new place, the new point of intersection, this is what's going to happen. Here it's a positive root and there it's a negative root, but I'm actually drawing this one wrong. It's supposed to still cut the x-axis. So here it is a negative root, here it is a positive root. The roots are the points of intersection of the two graphs. Okay, so moving on to the next question now. Okay, so the last question in question 5. 5.5 says the maximum distance between f and g in the interval where x is greater than the x value of a but less than the x value of b is k. Then they said if h of x is equal to g of x plus k, we need to determine the equation of h in the form of h of x is equal to this. Okay, so that you don't get lost in what they're saying, focus on the goal. The whole goal of this is to determine the equation of this h of x. And they said that h of x is made up of g of x plus k. Now, the good thing is we have g of x. That was that g of x is equal to x plus 5. We have that. What we don't have is k. So it means that we need to find k. So what did they say k is? They said k is the maximum distance between f and g in the interval where x is greater than x of a but less than x of b. That is what k is. Okay, so let's find that maximum distance. So since it is the distance between f and g in this interval, let's see what x of a and x of b refers to. X is greater than x of a but less than x of b. This is just the x coordinate of the point of a and the x coordinate of the point of b, which was, as we have here already, -5 for a and -2 for b. So let's just replace those. They're really just saying between this interval where x is greater than -5 but less than -2. So we have to determine the distance between f and g between these intervals. So this is what they mean by that. We have this graph and they want us to determine the distance between f and g between these two x values. Now, you see between these two x values, if we're looking at it like between here, this is the point where the graph of f is above the graph of g. So in order to find a distance for them, okay, or at least just the formula of the distance, you would have to take the y value of f and take the y value of g, and to find their distance, you subtract the graph of f minus the graph of g. And that's why they're giving you that hint that you have to take it between where x is greater than -5 but less than -2, because only at this point do you have the graph of f being above the graph of g. At every other point, like if you move this side, you see the graph of g is above the graph of f. So that's why they put that restriction, so that you have to say f of x minus g of x. Okay, so remember, they didn't just ask us to find the distance of that, but they specifically asked for the maximum distance. But let's try finding the distance of that first. So to find the distance of it, so just a general distance, not the maximum yet, you would take whatever the function of f of x is, and you would subtract it by the function of g of x. So that's what we're going to do to find that distance. So that distance is going to be equal to f of x minus g of x. Okay, then of course k would be the maximum distance. So let's go ahead and find what this equation will give. F of x was negative bracket x plus 3 all squared plus 4 minus g of x was the x plus 5. So because it has two terms, you have to include brackets. So we're going to put brackets and say x plus 5. So x plus 5. So let's simplify this. We have negative bracket x plus 3 all squared plus 4, and then if you multiply this in, we have negative x minus 5. Now, if you look at this equation, it should look familiar. We actually did deal with something like this. If we scroll up and look at this, you see when we made f of x equal to g of x, we actually had an equation like that. You see, where we had this equation and this equation had to come over, because really if you're saying f of x is equal to g of x, it's the same thing as taking g of x over. And so now you have f of x and g of x becomes negative minus g of x. So the equation that we get here at the end is the same equation we will get if we subtract this by that. So you can go ahead and work it out if you want to, but the answer is already here. So we might as well just take this, or even the final answer. So I will actually just take it from here because I can't actually take this answer. Here we were equating it to 0 and solving for x, but here we just want to find the distance. So it's like taking this part over like here. So I'm only going to take as far as this. negative x squared minus 7x minus 10. Okay, so I'm just saying that if you like, you can simplify that. It will give you this negative x squared minus 7x minus 10. It will definitely give you that. Okay, I'm not going to divide by -1 because this is not an equation. It's the formula for the distance of this graphs between those x coordinates. So this is an equation for the distance of it, but we're trying to find k. K specifically is what they call the maximum distance between F and G. Currently, we just have the distance between F and G, okay, where X is, of course, between these intervals. We need to find the maximum of that. That would be the value of K. So to find K, we're going to have to find the maximum. Okay, so what is the maximum value of this expression that we have? It forms a parabola. And because a, the first term, the coefficient of x squared is negative, it will be a concave down parabola. And so as you can see, this type of parabola has a maximum turning point. And that's what we're looking for. K is that maximum turning point. So to find that maximum turning point, if this was on the Cartesian plane, we first have to find the x value belonging to that, then take that and substitute it into the original equation for the distance, and we will get the y value of it, which of course will be our value of k, that maximum distance. So to find the x value belonging to this maximum or belonging to this turning point, there's two ways. You can use that x is equal to negative b over 2a, or we can just derive that equation and set it equal to 0. And I'll just use the derivative. So I'm taking the distance formula. I'll just call it d is equal to negative x squared minus 7x minus 10, the distance of this, okay? And I'm going to derive it. So I'm saying d prime is equal to this -1 times the 2 is -2, then x. We have to take a 1 from that, and it's just, we're left with a 1, which we don't have to rewrite. And then minus 7, and the x falls away, and that constant also just falls away. So this is what we have. So we've derived this. Now we have to set the derivative equal to 0. Okay, and just remember the whole logic behind that is you're looking for a turning point. At the turning point, that's where the gradient of the curve is equal to 0. When you derive a function, you're actually finding the gradient of that function. This is the formula for the gradient of this parabola at any point. So we're just setting that gradient equal to 0 so that it will find the turning point, because only at the turning point is the gradient equal to 0. So negative 2x minus 7. Then I'm going to take the negative 2x over, so it becomes positive, and we have minus 7. Divide both sides by 2, and x is equal to negative 7 over 2. Okay, so I found the x value belonging to that. It's negative 7 over 2. So of course I put the y-axis at the wrong place, so it will probably be somewhere like here. Okay, but we just have to find now we know the x value, we need to find the y value. The y value is your value for k, okay? So the y value would be, if we say d, where we're substituting negative 7 over 2, it's going to be negative bracket negative 7 over 2 all squared minus 7 bracket negative 7 over 2 minus 10. And then we'll just put this onto the calculator and let's see what we get. And when I put that onto the calculator, I get 9 over 4. So that maximum, okay, the maximum, or k, the value of k is 9 over 4. So k is equal to 9 over 4 because they told us what k was. It was the maximum distance between that. So we found the maximum distance. And now remember, the whole point of all of this was to find the equation of h of x. And so h of x is equal to g of x plus k. So know what g of x is, it's x plus 5. So we're saying that h of x is equal to the x plus 5, so x plus 5, that's the g of x, plus k, which is the 9 over 4. And so this is equal to x plus, and then if you calculate that, that's going to give us a 29 over 4. That would be the equation of h of x. Okay, so that's what they want. And that is the end of question 5. Okay, so now we're on question 6, and question 6.1 says a company bought a photocopier for 150,000 Rand on the 1st of July 2020. They will use the old photocopier as a trade in when they replace it with a similar new photocopier in 5 years' time on the 30th of June 2027. So 6.1.1 says the average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. Okay, so this company, they bought a photocopier machine for this price. So it means that in the present, like right now, they have this photocopier machine and this is how much it costs. They want to find out, since the rate of inflation is this, they want to buy a new photocopier machine, but this one is going to be in 5 years' time. So this is the one that is in the future. Okay, so it's going to grow. Okay, so because of the rate of inflation, the price of this will not be 150,000 Rand anymore. It will increase in value. And so something you need to remember is when we're speaking about inflation, then we're going to use compound growth formula. And that formula is A is equal to P bracket 1 plus I raised to the power of N. Okay, so in this case, the A value is going to be that final amount because this money needs to grow. So we're taking this is your P value because we invest in this and we need to grow it over 5 years. So that is the 150,000 Rand and then 1 plus, and the rate of inflation is 6.5% per annum. Okay, it's not compounded monthly or anything. So the interest in decimals is going to be 0.065 as a decimal. So plus 0.065 raised to the power of 5. Okay, so let's go ahead and see what this gives us. And on the calculator, this is what we get. We get 205 and then 5, 1, 12, but then you see 0.999. So it's money, it usually has to be rounded off to 2 decimals. So if you rounded off that 9, it will round up and then cause that 9 to become a 1. And so it will just round up until this 2 becomes a 3. So the money that we'll have here, the price of that machine is going to be 205,513 Rand. Okay, so that is the amount there. Then the next question. Then 6.1.2 says, calculate the trade-in value of the old photocopier after 5 years if it depreciates at 9%, a rate of 9% on straight line method. So it is depreciating first of all, and it is on straight line method. So this is simple decay, and the simple decay formula looks like this. A is equal to P bracket 1 minus I multiplied by N. Okay, so then another thing we need to look at is the fact that they said they need to calculate the trade-in value. So we have to find what is the trade-in value. Trade-in value would refer to your final amount because this is the money that machine can be traded in for. So it just means it cost a certain thing before, then over time it depreciated, then you can only trade it in for that amount. So that is your final amount. As you can see, the money here is going to decrease. Other words for trading value is things like this scrap value as well. Okay, so when you see those, that's what it refers to, that final amount. Okay, so we're going to have the amount that we're putting for P is going to be this present machine that they have. We want to know what is going to be the value of it when it depreciates. So it's our starting amount. So we have 150,000 and then bracket 1 minus the interest. Then the interest is 9% as a decimal, that is 0.09. And then multiply by N. So not to the power of N, multiply by 5. Okay, so let's go ahead and see what this gives us. And the final amount we get for A is 82,500 Rand. So that's how much that machine is going to depreciate to over 5 years. And that's how much they're going to be able to sell it for. Okay, moving on to the next question. So 6.1.3 says, the company set up a sinking fund to cover the replacement cost of the new photocopier machine. Okay, the minute you hear sinking fund, this has to do with future value. And anytime they speak about anything related to a savings plan where you're constantly putting the same amount of money every month or every quarter or every year, then that is where you're going to need future value. That's where you're going to use the future value formula. Okay, so they say the fund earns interest at 7.85%. Okay, so that is the interest per annum compounded monthly. Then they say the company made its first monthly deposit on the 31st of July 2022 and will continue to do so until the 31st of May 2027. And they're specifying that this is 1 month prior to the new photocopier being bought. Okay, when they're saying 1 month prior, so prior is just before. So 1 month before the new photocopier was bought. So that's going to be an important factor that we're going to look into. And the reason why is it's not like the normal ones they speak about where they tell us the payment started 1 month after. That's normal. In every future value or present value calculations, payments usually start 1 month after. But this is not the case. They are saying that they started the payment on this day and they will end on this day. But this is 1 month before the new photocopier is bought. So if they started on that 31st of July 2022, let me just call it June 2022, all the way to the 31st of May 2027, right? But this happens to be 1 month before they purchase the new photocopy machine. So this is the new machine that is being purchased. Then it means that the money, this is future value, meaning they're saving money. The money they've been saving at some point sat in the account for an extra month. So that's what that part means. It's not really like the usual 1 month after that they speak about. This is different. Okay, and then they say how much should be deposited at the end of each month so that the company will be able to buy the new photocopier. Okay, so how much must they deposit at each month? So that is basically the value of X. We need to find the value of X. So we're using future value. The future value formula looks like this. X open bracket, then 1 plus I raised to the power of N minus 1 all over I. And just remember, you also have a formula sheet, so you can always go back and check. Okay, so since this is our formula and we just need to find X, then it means let's just go ahead and fill in every other thing that we have. It means we should be able to find the future value. We should also be able to find the interest, which they actually told us the interest. That is this 7.85. In decimal form, you can put it as 7.85 over 100 and it's going to simplify it for you. So you can take it as 0.0785. And then another thing we would have to find is the value of N as well. Okay, so how many months is that going to be? Okay, so these are the things we can find, but when we do find them, we need to actually calculate the value of X. Okay, so we can start with the future value. The future value will be calculated like this. In sinking funds, when you want to calculate the future value or the amounts that they're going to need to save, you calculate it like this. So remember, they had this machine. They bought it for 150,000 Rand. Then in 5 years' time, this current machine they have is going to depreciate, and it depreciates to become this amount. Then they know that in 5 years' time as well, they're going to need a new machine, and that new machine is going to cost this amount. So they're not just going to throw this machine away, they're going to sell it. So if this was the amount that they actually needed for a new machine, but they're going to sell this amount, then you can calculate how much they actually need by saying this amount minus that. Since they're not throwing this away, they're going to sell it. So they're going to have that money as well to contribute towards getting this amount. So that's how we find the sinking fund amount. That's how much will be in the sinking fund. Or rather, that's the amount that they will need in the sinking fund. So that would be the sinking fund amount will be equal to that 205 and that minus this. Okay, and we're going to put this on the calculator and see what we get. And we get 123,013 Rand. Okay, so that's how much they need in the sinking fund. And that's really going to be our future value. Okay, so that is the future value that we're going to be using. Now, with this as well, this is compounded monthly, so this should be over 12. And then now to calculate N. So let's see what they said. They said that the company made its first monthly deposit on the 31st of July. Okay, so the first one was made on the 31st of July. And then they said, and will continue to do so until the 31st of May 2027. Okay, so this was in 2022. So we can go ahead and put that there. So this was in 2022, but they will continue to do this until the 31st of May 2027. So let's see how much months this is going to be, since it is compounded monthly. Okay, so a way that you can calculate this is, let's actually calculate it in terms of its years. So in 2022, how much months did they start depositing for? So they first started on the 31st of July. Okay, so July. And then we're going to have August, September, October, November, and December. Okay, so that is the 31st of December. So this is just the year 2022. This will be the amount of deposits they're going to make. So that is 1, 2, 3, 4, 5, 6. Okay, so here that is 6 months that they're going to be depositing for, seeing that they started here. Okay, so that's 2022. Then we can calculate their deposits for 2023. So in 2023, they're going to deposit from January the 31st, so Jan, all the way to December the 31st. So 31st December as well. And that from January to December of 2023, that would be 12 months. Okay. Then we can look at 2024. So in 2024, what's going to happen is, again, they will start depositing on the 31st of January and stop at the 31st of December. And again, that would be 12 months. Then in 2025, they're going to start depositing on the 31st of January again, all the way to December, 31st of December, and that would be 12 months as well. Okay, and then lastly, we're looking at 2026. So in 2026, they're going to deposit on the 31st of January and end on the 31st of December, which would also be 12 months. Now in 2027, they don't deposit all the way to December. They deposit from the 31st of January, and then they said that they're going to end here on the 31st of May. So let's calculate how much months that would be. So January, February, March, April, May. So till the 31st of May. And so that is 1, 2, 3, 4, 5. This is 5 months. So we're counting it as if this is the money that they are putting in. Okay, so the amount of installments that we have. So if we calculate all the way from the 31st of July here, all the way to the 31st of May in this year, this is the amount of months. So it's the 6 months. So N will be equal to the 6 months first, plus the 12 months, plus the other 12 months, plus this 12 months. And we keep going, plus this 12 months, plus that 5 months. So plus 12, plus 5. Okay, so you could just calculate it like that. And we already have how many sets of 12 here? This is 1, 2, 3, 4 sets of 12. So it's really just 6 plus 4 times 12 plus 5. And in total, that is 59 months. Okay, so N is equal to 59 months. Okay, so now we know what N is. That is 59. So 59 months. So everything is now ready to find X. So now we have to calculate the value of X. Remember, it's using the future value formula. I'm just going to copy this and put it down there. Okay, but there was also something that we really need to look at. So they said that they started depositing here on the 31st of July 2022. And then they will continue to do so until the 31st of May 2027. But then they said that this is 1 month prior to the new photocopier being bought. Meaning, like I said here, they started here, they ended here, but they're only going to buy the new machine a month after. Meaning the money, okay, that they keep depositing into this account is going to sit for an extra month. So this needs to grow by an extra month, and we need to apply this into our formula. So we'll apply it by doing this. All of this amount is going to give you your future value, okay? That's what this formula is for, to give you the future value. So we need to take that and now grow it for an extra month by multiplying it by 1 plus I to the power of the amount of months, and it's only growing for 1 month extra. And remember, the reason you say 1 plus I is because you want the future value itself, the money, okay, to be there, plus the interest as well, because this actually foils in like that. So that would be, when it multiplies by the 1, that will be the future value itself. And then when you multiply it by the I, it will be the interest of that future value. Okay, so when we're putting this in, we're going to have the future value, that's the amount we have, 123013 is equal to, then we have, I'm going to put this lower, it's going to look messy, and then we're going to have the x, and then open a big bracket, small bracket, 1 plus the interest 0.0785 over 12. So when you're filling these in, just be very careful. And we have to the power of 59, and then minus 1, close the big bracket, over the interest, which is 0.0785 over 12. And then, of course, this is being multiplied by this part. So multiplied by the 1 plus the interest, which is 0.0785 over 12, raised to the power of 1 month, if you want to say that. But it doesn't really matter. There's an invisible exponent on 1 here. Okay, so this is what we have now. Okay, so I'm going to try and calculate this in a way that it's going to look less intimidating, because the numbers, yeah, they look very complicated right now. So I'm going to focus on what are numbers here. Here we just have an x, and this x is being multiplied by this whole thing. But remember, this is being divided by this. So if you like, you could have said this entire thing here, all of these numbers divided by that, and it will give you a single number. And then that is being multiplied by this whole thing. So what we can do is, on the calculator, put this over that and multiply it by this. And it's going to give us a number in decimals, and we will not round off. Okay, so I'm going to put it in like this. Start with a fraction, and then open bracket, and then another bracket, 1 plus 0.0785, so 0.0785 over 12, and then we move out of the bracket, close that bracket, raise it to the power of 59, then come down, and then we need to say minus 1, so minus 1, we close the bracket, and then we go over 0.0785 over 12. I'm just trying to be careful here. Then, okay, so that part is done. And just check and make sure that everything's okay. Okay, and then we're going to multiply by this little part here. So multiply by 1 plus 0.0 and then 785 all over 12 raised to the power of, so come out of that, close the bracket, raise it to the power of 1. You don't have to do that actually, because there's actually an invisible exponent of 1 there. Okay, so this is the number it gives. Just make sure you check that everything is in properly. So this is really what I'm saying. Here we just have the 123,013 is equal to. Then we have the x being multiplied by everything here. So it's like x multiplied by the 72.19028,117, and just you can just say dot 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 just to show you did not round off yet. Okay, and now to solve for x, to get x to be on its own, we will just have to get rid of this number. So we'll divide both sides by 72.1902 dot dot dot, divide both sides by 72.19028. 1902 dot dot dot. Okay, so I'm solving for x here. Now, there's a button on your calculator that's going to be very useful, and it's this button called ans. So it is the answer button. Whatever amount you calculated here is recorded in this button. So if you remove everything here, if you press AC, which I'm going to do, if you press AC, it's going to show you the last answer that it recorded. So we really need to just say this 123,013 and divided by this amount. So you can divide it by that amount, or you can say 721902 to them, but then on your calculator divided by ans, because that amount has been recorded in there. Okay, so on your calculator, mine works a little differently. You can press the AC button, then you put this amount in and say divide by ans. So over ans, or even if you use division, it will still work. Okay, so on my calculator, I just have to first say is equal to, and then I'm going to say that 123013, and then over ans. Okay, so this is how much we get. So over ans, we get 1,704 rand and 01 cents. Okay, so that's the amount. This is how much they need to keep putting into this account for that 5 years in order to be able to buy a new machine. Okay, so that is this question 6.1.3. Okay, in financial maths, just be really careful with the numbers. You know how it is. They always put complicated numbers and try to simplify things the way you can. That answer button is very useful on the calculator. Okay, so moving on to the next question. Okay, so 6.2. Today, Andrew borrowed 200,000 Rand from a bank. The bank charges interest at 5.25% per annum, compounded quarterly. Then they say Andrew will make repayment of 6,000 Rand at the end of every 3 months. His first repayment will be made 3 months from now. Okay, that is normal. Okay, and the reason I'm saying this is normal is because when you get a loan, for example, so if you get a loan on this day, T0, you always have to start paying back the loan a period after. And when I'm saying a period after, I just mean, for example, if your interest was compounded monthly, then you need to start 1 month after. So if your interest was compounded quarterly, you have to start 1 quarter after. And a quarter, okay, 1 quarter is actually equal to 3 months. So it makes perfect sense that they're saying that his first repayment will be made 3 months from now. Okay, because that's just how loans work. Okay, so how long in years will it take Andrew to settle the loan? Because they're already speaking about loan, we are going to use present value. Present value always calculates the repayment on loans. So present value formula is X, and you can always just go back to the formula sheet. X brackets, then we have instead a 1 minus bracket 1 plus I raised to the power of negative n, close bracket, over I. So that's our present value formula. Okay, so with this formula, we can find all the things they are asking for. So the first thing we're going to look for is, they said, today Andrew borrowed this amount. This is his loan amount. So the present value is this amount. You can see present value as, present value is really how much do you owe. So since Andrew went to the bank today and borrowed this amount, today he owes 200,000 Rand. So that's his present value. Okay, so he owes this amount today because no month has passed yet for there to be interest. And then we also find out that they also tell us the interest, 5.25% compounded quarterly. So our interest is in decimal, 5.25 is 0.0525, and then it's compounded quarterly, so we put it over 4. Okay, and a way of looking at that is like, this is the yearly interest. They say per annum, compounded quarterly. This is the yearly interest that they give him, but then it's going to be compounded quarterly. So he's going to be charged interest every quarter. Then they also say Andrew will make repayments of 6,000 Rand, okay, at the end of every 3 months. That is normal. At the end of every 3 months, 3 months is a quarter. So the repayment amount, that is going to be your X value. So X is the 6,000 Rand that we have. At the end of every 3 months, and they say his first repayment will be made 3 months from now. That's fine. So the question is, how long in years will it take Andrew to settle the loan? Okay, so how long in years? So this one, it doesn't really seem like they put in anything complicated. It just seems like a normal type. So we're just trying to find N. Okay, so they probably just want to test your use of log. Okay, so let's put this in. So present value 200,000 rands is equal to, and then we have X 6,000 rands, and then that is 1 minus 1 plus the interest is 0.0525 over 4 raised to the power of negative n. We don't have that. Okay, there's something that I can't just leave n like this. It wouldn't make sense. So n, the value of n itself, that would tell you your years. Because you notice when they tell us, let's say the person had a loan and they had to pay it in 10 years, then you would say 10, and then if it was compounded monthly, you'd say 10 times 12. So that N stands for the years. Since they said they want the answer to be in years, I'm going to actually keep this as this. I'm saying that whatever my years was is being compounded quarterly. So I'm going to multiply that by 4. And here I'm going to be using 4n. Now notice 4n is going to stand for the quarters. I'm still going to convert that into years by dividing both sides by 4. Okay, so this will be the quarters so long. So we're raising it to the power of 4n as the quarters. Okay, over the interest, which is 0.0525 over 4. Okay, so in this one, we have to make this the subject. So we have to find a way to simplify this so that we don't make mistakes and we're able to find that n. Okay, first of all, what I will do is this 6,000 is being put over this. Okay, we can actually say this divided by that, and that amount, we'll just put it in front of this big bracket. So I'm going to say the 6,000 over this. Okay, instead of over, let's use the division sign. 6,000, since we're dividing by a fraction, divided by 0.0525 over 4. Okay, so that's the amount that we get. Can it be put as a fraction? Yes. Okay, so I would rather use it as a fraction because the fraction does not round off. So it just means here on the left hand side we still have the 200,000, and then on the right hand side we have this number. So just count the zeros and see how much this is. That's 3 zeros. Okay, so it's 3,200,000 all over 7, and this is being multiplied by everything in here. So I'm also going to try and simplify some stuff here inside this bracket here. So we have now 1 minus, this can be simplified. Okay, so I'm going to say 1 plus this 0.0525 over 4. As a fraction, this is what that gives. So I'm going to leave that as a fraction. It's better as a fraction. It's easier to use. So it's 1621 over 1600 to the power of negative 4n, and then close that bracket. Okay, so this is what we have. We're still trying to solve for this. Okay, since we're trying to get into this, you need to get rid of this one first, so that you can break into the bracket. So to get rid of this, you're going to have to divide both hand sides by this 3,200,000 over 7. So dividing both sides by that, 3,200,000 over 7. So this part is going to cancel. And now we just have this over here. Now the bracket is open and we have 1 minus, and then 1621 over 1600 to the power of negative 4n. And let's see what this part is going to give us. So we're going to say 200,000 and divided by, I'm going to use the division sign, not a fraction, because this is already a fraction. 3,200,000 over 7. And it gives us a nice simple fraction. It gives us 7 over 16. So 7 over 16 is equal to all of this. Okay, so that's just 7 over 16 that we have here. Okay, then we can go ahead and take the 1 over, and we're going to get, we'll have to say minus 1. So it's the 7 over 16 minus 1 is equal to this. Now remember, there's still a negative in front of this. It's a minus, and we have 1621 over 1600 to the power of negative 4n. So when we take this number and we just say minus 1, it's going to give you negative 9 over 16. So negative 9 over 16 is equal to this. And you can see they're both negative. So we just have to get rid of that negative by dividing both sides or multiplying both sides by negative 1. You can actually just do that. Times negative 1 times negative 1. And to just get rid of that. So on here, just make sure you say times negative 1. Just so that you know you have the positive answer there. So we have 9 over 16 is equal to then the 1621 over 1600 raised to the power of negative 4n. Okay, I think we're at the final stage of this now. So we need to solve for this. To make an exponent a subject, you're going to use log. So we're saying negative 4n, which remember, the negative 4n is really the quarters. We're still going to put it in years. Is equal to log, and the base is this base, the thing carrying the exponent, 1621 over 1600. And then here we're going to have the 9 over 16. So that's why I put it in fractions, because it's just easier to work with like this. And it really helps you just to avoid mistakes. So I'm going to say log. Remember, use this log, not that one, the one with the base. So log, and our base is 1621 over 1600. And then here we're going to have the 9 over 16. Okay, so this calculator is obviously given it in this form. I just have to put it in decimal form. So it says that negative 4n is equal to negative 44.12435, and this keeps going. But we need to find the answer of n. N will tell you the months. Negative 4n, or 4n is just telling you the quarters. So divide both sides by negative 4. So I'm going to take that answer and divide it by negative 4. And n is going to be equal to 11. So round it off to 2 decimals, that's going to be 0.3. Okay, and I'm going to say years here, and I'm going to actually leave the answer like this. I don't want to say 11 years. Technically, it's like 11 years, but I'm just thinking about it like, because it has 0.3, at exactly 11 years, like if you take the number n is equal to 11, right? And you put it into this formula, into the present value formula, and you check, you see that if you put n as 11 here, you're not going to have exactly 200,000. So meaning, technically speaking, the loan is not completely paid off yet. So to be safe, I'm going to just leave the rounded up answer like this and say this is the amount of years it's going to take. But honestly, I feel like if you said 11, it will still be fine. So I'm going to take that, and that is the answer for that question. Okay, so that is the last question. Question 6 is 13 marks. And now we move on to question 7. And now we're on question 7. And 7.1 says we have to determine f prime of x from first principles if f of x is equal to negative 2x squared minus 1. Okay, so since you have to do it from first principles, you can actually just find the answer first so that you know what your answer needs to look like. If we derive this using the rule of differentiation, we will say f prime of x is equal to the negative 2 times the 2 is negative 4. Then we have x minus 1, which is 1. We don't have to write the 1. And then we have a constant. It falls away. So you know that this should be your answer. Okay, so when deriving this from first principles, you can start with this formula, the f of x plus h. Let's find out what that is equal to. We already know what f of x is. So this just means that whenever you see x, replace it with x plus h. So this is going to be equal to, we have the negative 2, there's an x, so replace it with x plus h. Then we have a squared, so all squared minus 1. Okay, so simplify this further, it's negative 2. Then we have to square this. So it's 2 brackets being multiplied by each other. So square the first term, that's x squared. Then square the last term, that's plus h squared. Then the first term times the second term, that's going to be xh, then times that by 2. So that is positive 2xh. Okay, then minus 1. So this is what we have. And then remember, it's a closed bracket here because this still needs to FOIL in. Then we're multiplying in the negative 2 into these 3 terms here. And so we will have negative 2x squared minus 4xh minus 2h squared minus 1. And that is your f of x plus h. So the formula to calculate the derivative of this from first principles is f prime of x is equal to the limit as h approaches 0, and then we have f of x plus h minus f of x all over h. So this is equal to the limit, again, as h approaches 0, and we have f of x plus h, which is all of this. So put that in carefully. Remember, this is like 5 marks. That's really a place where you can score marks. So minus 4xh minus 2h squared minus 1. Then we're saying minus, and remember, you're subtracting it by something that has more than one term, so you need to put brackets. So minus, open a bracket, and we're going to say minus negative 2x squared minus 1 all over h. Then we have is equal to the limit as h approaches 0. We'll repeat everything that we have there. Just make sure to be careful as you write everything down. And then this negative is going to multiply into that. And so we have now a positive 2x squared, and we have a positive 1 all over h. Now, the thing about this is things are going to cancel here, and you don't have to really just search. You know that what you subtracted by, that's the only thing that's going to cancel. Okay, so if you have a positive 2x squared here, it will cancel with a negative 2x squared. If you have a positive 1, then there must be a negative 1. So the positive 1 cancels with negative 1. They just become 0. So long we just have, again, the limit as h tends towards 0. We keep writing this until we substitute. So negative 4xh minus 2h squared. That's all we have here, okay? And then all over h. Then we have to take h out as a common factor. So we still have the limit as h approaches towards 0, and you only take it out so that it can cancel, and you don't get to substitute 0 into here because that will make it undefined. So to find out what is here, it's like saying, what do you multiply to h to get back to negative 4xh? Or you could just say this, negative 4xh divided by h. H's will cancel, you're left with negative 4x. Same thing here, this divided by the h. One of the h's would cancel here, and you'll be left with negative 2h all over the h. Okay, so here's your h's cancelled in, and then I'm going to just substitute already. So I don't want to rewrite that again. I'm saying negative 4x minus 2, and in place of h, I'm going to put 0. So f prime of x is going to be equal to, this times 0 just stays 0, so negative 4x. And as you can see, we got the same answer using the rule. Okay, so that is 5 marks. So 7.2, we have to determine 7.2.1 f prime of x if it is given that f of x is equal to this. So we just have to derive this. This is already ready to be derived. So f prime of x is equal to, we're saying the negative 2 times the 3, negative 6, and then x to the power of 3, then you have to take out a 1 from the exponent. So that's going to be squared. And then you have the positive 3 as the coefficient times the exponent of 2. That gives you a positive 6. And then you have x to the power of the 2 minus 1, which of course gives you a 1, but you don't have to write that 1. Okay, so when we derive that, that's all we get. And that is for 2 marks. Okay. So 7.2.2, we have to determine the derivative if y is equal to 2x plus 1 over the square root of 4x. So sometimes you have to make sure that the equation or the function that you're going to derive is ready to be derived. You see, in this one, you have a square root. Now, the square root is not necessarily a problem. If you just had square root of 4, it's not a problem. The problem is the fact that x is in the third. X should not be in the third, and it also shouldn't be on the denominator. Okay, so we're going to have to fix that first. So we just have y is equal to 2x plus the 1 over the square root of 4x. Okay, so the square root of 4. 4 can be square rooted. So we can simplify that. So this is very different from something like this. If you had 4 plus x, you can't square root this because you cannot square root across terms like that. But this 4 and the x are being multiplied, so we can. So we can have y is equal to 2x, then plus 1 over, the square root of 4 is 2. But the square root of x is still the square root of x. So this is what we're going to have, 2 square root x. And then now the new problem is the fact that this is still on the denominator and it's also a third. So let's first change it to not be a third anymore. So we will just say y is equal to 2x plus 1 over, then we have the 2. Now the x, this is what's actually going on here. It's a square root. So here, the exponent that we have here, it's actually a square, just like when you have cube root. Okay, it's a 3 there. So there's an invisible 2 here. And in front of every number and variable, there's a natural exponent of 1. So we can actually rewrite this like this. We can say x, and then we're going to raise it to the power of, you always say the inside exponent over the outside exponent. So that is 1 over the 2. So that's how we can rewrite that. And then now the new problem is that the x is still on the denominator. We need to take it to the numerator. But when you take it to the numerator, it's going to cause its exponent to become negative. Okay, so we have y is equal to 2x plus, and so now I'm moving this x to the numerator. 1 is kind of like standing as a placeholder here. Because there's already going to be an x on the top, I don't have to rewrite the 1. That's like saying 1x. There's no need to say that. So we have x to the power of, that half now becomes negative a half, and we have over 2. Okay, now in this case, I'm actually going to leave this 1 here. The reason why is because we need to have a number here. So that 1 in front of the x, I'm actually going to leave it here. So we have a 1 in front of the x, and this is the reason why. So I'm going to say y is equal to, we have 2x, then plus, and I will rewrite this like this. We say 1 over 2, and then we have x to the power of negative a half. See it like this. The 1 and the x to the power of negative a half are being multiplied. You could move this away and let the 1 carry the denominator of 2. Because this is just a separated form of this. We could have just said, if we said x to the power of negative a half and we put this over 1, you see the fact that these two are next to each other, they're actually being multiplied. So if you wanted to get it back to this point, you multiply the numerator and the numerator, which would give you that, and then the denominator and the denominator, which would give you the 2. Okay, so we can actually just write it like this. And now this is ready to be derived. So we'll say dy over dx is equal to, and so let's derive this. It's the coefficient times the exponent. There is a natural exponent of 1 on top of the x. So it's going to multiply by that. And so you have 2 times 1, which is 2. Then we have x to the power of this 1 already that is already there. But then you have to subtract 1 from the exponent. So minus 1, which would give you a 0. And anything, so it's x to the power of 0. Anything to the power of 0 gives you 1. And 2 multiplied by 1 just gives you the 2. So that just stays 2. Then we come to this part. It's the positive half as the coefficient multiplied by a negative a half. And that will give you negative 1 over 4. Okay, you can be using the calculator for this. Then we have x to the power of, we still have our exponent, and we're going to subtract 1 from it. So 1 can look like, you can also just calculate that on the calculator. So 1 can be written as 2 over 2. I'm just writing it in a way that the denominators are the same. So dy over dx is equal to 2 minus 1 over 4 x to the power of, so I'm saying negative 1 minus 2, which is negative 3. Over, and then the denominators stay the same because we are subtracting. When you're adding or subtracting, your denominators must stay the same. So over 2. Then lastly, you can just write this in a way that the exponent is positive. So this is just dy over dx is equal to 2, then minus. Remember that this x is actually on top. It's on the numerator. So we need to take it to the denominator so that its exponent will be positive. So we have 1 over, the 1 is still there, 4, and then the x comes here now. And then the exponent is now positive 3 over 2. So this is the derived form of that function that we had. Okay, so that is 7.2.2. Then 7.3 says the graph y is equal to f prime of x. Okay, so this is already a derived graph. Has a minimum turning point at 1 and -3. Determine the values of x for which f is concave down. Okay, so the fact that they're saying y is equal to f prime of x, that derived graph already, has a minimum turning point. When you're thinking about something that has a minimum turning point, we can imagine a parabola that is concave up. This will have a minimum turning point. So if this is the equation of y, okay, because this is the y is equal to f prime of x, this is the graph that has been derived already. So if this is the derived form of this graph, okay, this is f prime of x, then the original graph must have been a cubic function with the a value being greater than 0. Okay, so you have to think about it like this. The cubic function, the equation of it looks like this: ax cubed plus bx squared plus cx plus d. If you derive this, okay, so y prime, if you derive this, you're going to get this a, because if a is greater than 0, it's going to look like an n, okay, a capital letter N, looking like this, okay, but just more curved. So that's how it looks. And so if you derive this, you're going to get a parabola. So you have to think about it like this. This 3 is already positive, and you have to multiply it by the coefficient of x. If this is positive and you're multiplying it by a positive, then this 3a, this value, is a positive number. So you have now x squared. Then, of course, the b times the 2 will give you plus 2bx and 2bx. And then you have 2 minus 1, which is, of course, 1. Then you would have plus c, and the d would fall away because it's a constant. It doesn't have x in it. So you see, this would be the equation of a parabola. And you can see that the coefficient of x squared is positive. 3a is positive because a was positive and 3 was a positive number, and they multiplied. So it will create a concave up parabola. So that's what I'm saying. The only way we can have this kind of graph, if this is f prime of x, it must mean that the original graph is a cubic function that has the a value being greater than 0, meaning it looks like this. Okay, just also remember, if a value is less than 0 in a cubic function, the graph will just be like a backwards n, okay, but more curved. Okay. Now, I don't really need this part. I was just trying to explain that and where that comes from. So they're saying if we have this graph, that f prime of x, that y is equal to that, it has a minimum turning point at 1 and -3. So 1 and -3 is the minimum turning point. This is f prime of x's minimum turning point. Okay, then the question is, you need to determine the values of x for which f is concave up. The blue one would be a graph of f. That's the original one. That's the derived one. So where is it concave up? For you to find out how it's concave, you need to know what the point of inflection is. Okay, just also remember, when we're looking for concave down, so here, this part would be concave down. That is curved downwards. And then this part would be concave up. Okay, it's like a parabola, like we have a concave down parabola and a concave up one. So we're also looking at that here. But we need the point of inflection to be able to find out for which x value this thing would be concave down, because we need to take this blue part. This is concave down. So with this, you have to remember that if we have a cubic function and we derive that cubic function and it gives us the parabola, this turning point, the x value of the turning point, is also going to be the x value of your point of inflection. Okay, so the point of inflection's x value is also 1. So we just have to find out where is it concave down. So the highlighted part in blue, that's where it's concave down. Okay, starting from whatever x value this is, and we know now it's 1. So imagine you had a y-axis. Okay, and for the sake of this, I'm just going to get rid of that. I don't really need that part. So we want to find out where's the concave down. So it's concave down all through here. If this x value, the point of inflection's x value, is 1. And then these are all the places that it's concave down after 1. So here, moving to the left, you see, look at all the points for which this graph is concave down. All of these points are concave down, and look at the x values. They are values that are what than 1. These are values that are less than 1. That would be the value of x for which it's concave down. So you can conclude and say that x needs to be less than 1. Okay, so that is 7.3, and that's the last question in question 7. Okay, so we're on question 8, and question 8 says, given f of x is equal to x cubed plus 4x squared minus 7x minus 10, we have to write down the y-intercept of f. Okay, so when we have to find the y-intercept, just remember that you only have to just make x equal to 0. But there's an easy way to see the y-intercept. So remember that this cubic function is in standard form. And so the y-intercept will be the last number without a variable in it. So that would be d. That is your y-intercept in the cubic function. So the y-intercept is where y is equal to negative 10. As a coordinate, the x value is 0 and the y value is negative 10. So you can also go ahead and make x equal to 0 and substitute in place of x 0. You will get negative 10. Okay, moving on to the next question. They want you to show that 2 is a root of the equation f of x is equal to 0. Okay, so for 2 to be a root, meaning it is an x-intercept, it really just means that if you take this, you have to take 2 as an x value. And if you substitute it into the equation of f, it should give you 0 as your y value. So that will prove that it is a root. So I'm going to take the function of f of x and I'm going to substitute in place of x. I'm going to substitute 2. And it's equal to 2 all cubed plus 4 multiplied by 2 all squared minus 7 multiplied by 2 minus 10. Okay, and you can go ahead and put that into the calculator and see what you get. And when we put that into the calculator, you see you get 0. So I guess here you're just getting a mark for substitution and for your answer. Okay, then moving on to the next question. 8.3 says, hence factorize f of x completely. Okay, so since we know that 2 is a root, we have to factorize f completely. So the fact that they told us that 2 is a root, it helps us to factorize. Okay, so this is the equation of f of x. So the method we're going to use to factorize this is synthetic division. Now, when using synthetic division to factorize, first you're going to focus on the constant in this function. So we have negative 10 as the constant, being the only number without a variable. So we look at that constant and we take factors of that constant. So the factors of negative 10 would be things like negative 1 and 1, negative 2 and 2, 5 and negative 5 as well, right? But we don't have to do this anymore because the whole point of doing this is so that you can take these numbers, these factors of negative 10, and substitute it into the equation, okay, into the function, and the one that gives you 0 is your root, and we use that number in our synthetic division. But we don't have to do all of that because we already know they told us that 2 was a root. So we already know which number here will work. It's 2 that's going to work as one of the factors of negative 10. These aren't all the factors of negative 10, by the way. So since we already know that, it means we can skip that step. We know that 2 is a root. Okay, so this is how we're going to use it. We're going to put 2 on the right hand side, and then we're going to draw a capital letter L, but we're going to draw it backwards. So a backwards L, which would look like that. Okay, and then after we have drawn that, now you're going to look at all the coefficients in f of x, all the coefficients of everything here. So the coefficient of x cubed is a 1. So we're going to put 1 here. Then the coefficient of 4x squared is that positive 4. So we'll put a positive 4 here. And then, of course, the coefficient of x is negative 7. So we have minus 7. And lastly, we have the negative 10. Okay, then the first thing you do is, you see this 1, you drag down the 1. Then we're going to say 1 multiplied by 2, which gives you 2. And we put that answer on top of here. Then 2 plus the 4. Okay, we take whatever sign is here. That is 6. Then again, 6 multiplied by 2, which is 12. Then 12 minus 7, that gives you 5. Then 5 again multiplied by 2 gives you 10. And lastly, 10 minus 10 is 0. And this is one thing, you should always end with 0. If you didn't end with 0, it means you must have miscalculated somewhere. So just always make sure you end with 0. Okay, so this is how it's factorized. Remember that 2 was already a root. So if we're factorizing f of x as it is, if 2 is a root, so it just means that when you were simplifying, when you said f of x is equal to 0, 2 was one of your solutions, meaning x was equal to 2. But now we need to see what the factor was. So to find the factor, it's like taking the 2 over the equal to sign. And so the factor is actually x minus 2. So x minus 2 is a factor, but x is equal to 2 is one of your roots. So we're going to put, this is the first factor we have, x minus 2. And then to find the other factors, we are going to use the coefficients of these numbers that we found here. And how we use them is like this. 1 is the coefficient of x squared. 6 will be the coefficient of x. And 5 will be your constant, the number without a variable in it. So when we write down these factors, it's really 1x squared, but we don't have to write the 1. It's just the x squared. And then we have a 6x, so it's positive. So it's a positive 6x and then a positive 5, so plus 5. And that is our second factors. Okay, so we still have to factorize this part further. So that would be f of x is equal to, then we have x minus 2. And then we factorize this. So open up 2 brackets and we're going to have x multiplied by x is what gives you x squared. Then we have to ask ourselves, what multiplied by what will give us a positive 5, but that can help to give us a positive 6 in the middle. Also notice everything is positive. So factors of 5 would be positive 1 times positive 5. That would give you the positive 5. And of course, if you see you have positive 1 plus 5, it would give you the 6 in the middle. Okay, so these are our factors and now it is factorized fully. Okay, so that is for 3 marks. That's what you get for 3 marks. Then moving on to the next question, 8.4. If it is further given that the coordinates of the turning points are approximately at 0.7 and negative 12.6, and then this as well, negative 3.4 and 20.8, draw a sketch of the graph of f and label all intercepts and turning points. Okay, so they gave us turning points. They gave us the stationary points or our turning points. So we know what those are. Now we can just go ahead and put down our intercepts. Okay, so we have that f of x being factorized, but we just have to find the x-intercepts of this. So to find the x-intercepts, you're going to make y equal to 0. So make that equal to 0. So really what you have is 0 is equal to, and then you have x minus 2, bracket x plus 1, bracket x plus 5. And it works with the same logic as quadratic equations. You're saying something times something times something gives you 0. So we're going to say either this first bracket is equal to 0. Therefore, we're saying that either x is equal to 2 or x is equal to negative 1 or x is equal to, take the 5 over, negative 5. So those would be our x-intercepts. Okay. Then also to find the y-intercept. So you can put it as coordinates as well, just to remind yourself. That's 2 and 0. This one will be negative 1 and 0. This one is negative 5 and 0. Okay, the y-intercept, we already have that. So the y-intercept is this over here, 0 and negative 10. So we can also just put that down. Our y-intercept is 0 and negative 10. And then, of course, they gave us the stationary points. Okay, so one thing about this graph is, apart from the stationary points and all the intercepts, you have to know the shape of the graph. So the shape of this graph, since the equation of it is x cubed plus, and then this keeps going on. But remember, we have x cubed, meaning the coefficient of x cubed is 1. It's a positive 1. So it means that a is greater than 0. And when a is greater than 0, your graph is going to form a capital letter N, but it's just going to be a more curved one. Okay, so to draw this graph, we already know the shape of the graph. So what I'm going to do is I'll just put, I don't know where the X and the Y axis is yet. What I would actually do is draw the graph. I know what it looks like. It looks like this. So that's what I'll do first. And then now we can start figuring out where the other things are. Draw the graph first, then you can draw the X-axis. Okay, now that the X-axis is there, let me just make this line straighter. So there's the X-axis. Now we can just put down the X-intercepts because that will help us to just know where exactly the Y-axis should go based on these numbers here. So the X-intercepts we have is, the smallest one first is -5, then -1, and then 2. Okay, so I'm putting it down like this. I have -5 over here, then I have -1 over here, and then the 2. So from this, you'll be able to see where the y-axis is going to be. Since this is -5, -1, then you know after -1, you should have 0. And when you have 0, that's where your y-axis is going to be. Then, of course, you have the 2. So that's what I'm going to do. I'm going to draw the y-axis just after that -1. So the y-axis can be here. Remember, they don't really care too much about you writing numbers. They just want to see the shape of the graph is right, your intercepts, even the y-intercept as well, and the turning points. Okay, so here's the y-axis, and now I'm going to just go ahead and put down that y-intercept. So the y-intercept was 0 and -10. So 0 and -10. All I have to do is say that it's intersecting here at 0 and -10, or you could even write the -10. You can write it as coordinates, it's fine. So -5 and 0, and we have -1 and 0, we have 2 and 0. Over here we have the 0 and -10. And then of course we're going to have the turning points. So the turning points are just going to be the one here and the one there. Also just look at where the numbers are going to be. You see this one, the X value should be smaller than the X value you're going to have for this one, because this one is more further to the right. So let's see which one has a smaller X value. So we have the 0.7 and the -3.4. So this one definitely is the one that we have here. Okay, so this one's is going to be -3.4 and the 20.8. Okay, so 20.8. 20.8. That's that turning point. And then this one over here is going to be there's 0.7 and -12.6. So 0.7 and -12.6. There we go. Okay, so not really perfect, but it's a quicker way to draw the graph because they really just want to see the shape is right and you have all your intercepts and your turning points. Plus in the memo, that's usually how it looks. They don't really have numbers in the memo. And of course, because the name of the graph was, the name of the equation of the graph was f of x, we can go ahead and name this graph f. Okay, so that is a method you can use to draw your graph. First, start off with the shape of the graph. Actually draw the graph. So the shape of the graph, whether it looks like that or like that. You can even use this trick for the parabola as well. Works well with the parabola. Secondly, you put down your x-intercepts. Then you're able to find your y-axis based on that. Okay, so y-axis. Then you put down your y-intercept. And lastly, you're able to find your turning points. Okay, so those 4 steps would really help you with sketching the graphs. Okay, next question. So the next question is 8.5. Use your graph to determine the values of x for which f prime of x is less than 0. So when they say f prime of x, what do they mean? So f prime of x, when you derive a function, what you're finding in that function is the gradient of the function at any point. So when you say f prime of x, it's really speaking about gradient. So this question is really saying, where is the gradient less than 0? Okay, so let's try and understand what positive and negative gradients mean. When you have a line that is doing this, okay, you read functions from the left-hand side all the way to the right-hand side. What is this line doing moving from the left to the right? You see that this line is increasing. And so when a line is increasing, it means its gradient is positive. Okay, that's what increasing functions do. They increase moving from left to right. And so it means that if you have a line that looks like this, and you again read it from left to right, it means that this line is decreasing. So we're reading it from left to right and you see it's moving down. So the gradient of this graph is negative. That means it is decreasing. Now we do the same thing with curves as well. So we're only just looking for where is the curve, where is the gradient of the curve negative? In other words, where is the curve decreasing? So if we look at this graph, where is it decreasing? So let's just go ahead and check what it is doing throughout. We're going to start from the left-hand side, moving to the right. Over here, reading it from left to right, look at what this part of the graph is doing. It is increasing. Then it reaches the turning point. Now at the turning point, it neither increases nor decreases. And that's why at this point it is stationary. This is a stationary point. And then after the turning point, look at what it starts to do. It starts to decrease. Then it reaches another turning point and it stays stationary, and then it starts to increase. Remember, we're looking for where f prime of x is less than 0. In other words, where is the gradient smaller than 0? Where is it decreasing? And this graph is decreasing here. So all the way through here, and it is decreasing. Okay, so let's find out which x values exactly belong to that part of the graph, because we always have to answer them in terms of x. Okay, so the x value that belongs directly to this point is negative 3.4. Okay, so that's the negative 3.4. And also let's just mark the x value that belongs to this endpoint as well, since it only decreases from here to here. So that is the 0.7. So notice what it's doing. If we line these parts of the highlighted graph to the x-axis, you see that these points are points that are what than negative 3.4. They are points that are greater than negative 3.4. You see, because they are on this side, on the right-hand side of negative 3.4. But what than 0.7? You see that these points, look at where they are. They are on the left-hand side of 0.7, so they are less than 0.7. So this is really how we can write this. We can write this as a single inequality. We're saying that x needs to be greater than negative 3.4. So it needs to be greater than negative 3.4, but less than 0.7, but less than 0.7. And that would be the values of x for which this graph has a negative gradient, or where f prime of x is less than 0. Okay, so that is where x is greater than negative 3.4, but less than 0.7. Okay, moving on to the next question. Then the next question, 8.5.2 says, the gradient of a tangent to f will be a minimum. So we have to determine the values of x for which the gradient, okay, of a tangent to f will be a minimum. Okay, so let's break this down. The gradient of a tangent. Let's just understand what that means. They're really just adding too much words. I feel like this word tangent is unnecessary in this. But just think about it like this. The gradient, okay, of a tangent. When you have a curve and you have a tangent to that curve, so no matter what the curve is, whether it's a parabola or a cubic function, let's say you have a tangent drawn to a curve at a specific point, because tangents only ever touch a curve once. So understand that when they're saying the gradient of a tangent to f, this is what they're saying. The gradient of this line to this graph, okay? The gradient of the tangent to f and the gradient of f at the specific point, they're exactly the same, okay? They're equal at this point. So if the gradient of a tangent, of this tangent, let's say it's 2, then it means that the gradient of the graph at this point is also 2. So let's just establish that when they're speaking about the gradient of a tangent to f, let's just understand that part as the gradient of a point on f. So since the gradient of the tangent to f is exactly the same thing as saying the gradient at this specific point on f, if it's exactly the same, let's just skip this word tangent and let's actually speak about the gradient of f at a specific point. So if we rewrite this question, this is really what it's saying. So the question is really just, where will the gradient of f at a point be a minimum? And now we can think about what the gradient of f is actually speaking about. Remember that f is a cubic function, right? If we're trying to find the gradient of f, it means you need to derive the graph of f. And if you derive the graph of f, it's going to form a parabola. If this one is positive, if this one, its a value is positive, when you derive this, it's going to form a concave up parabola. Okay, so this would be the derivative of f. In other words, this function represents the gradient of f. So this is what they're actually speaking about. The gradient of f refers to this parabola. The question is, where will this parabola be at a minimum? Or where will this parabola have a minimum value? So you see now, since it's a concave up parabola, it will definitely have a minimum value and not a maximum value. See this, it comes from infinity going down, and then at this point it turns and starts to increase. This would be the lowest point on this parabola. That is the minimum. So the question is, where will this graph be at a minimum? They want you to answer them in terms of x. You just need to find the x value belonging to this minimum point on this parabola. Okay, because the parabola stands for the gradient of f. That's really what it is. So let's find that minimum value. Okay, let's find the x value belonging to that minimum value. We can first of all start by drawing this derivative of f, that parabola. We can draw that graph. So that graph is going to look like this. So when we're drawing this parabola, the thing about this parabola is that we actually know the x-intercepts of it. You see the x value of your turning point, that negative 3.4, is going to be the same x value of your x-intercept of your parabola. And then the other turning point as well, the 0.7, that is also going to be the x value of your x-intercept of your parabola. And remember, your parabola will be concave up because this one, the a value is also positive. So our graph is basically going to look something like this. The parabola is going to go like that and like that. So something like that. Not really a perfect one, but okay, let me try again. So like this, and then moving up like that. Okay, that looks better. So that will be f prime of x. Okay, this is the derivative of that function, that cubic function. And we just have to find its turning point, but not really the full turning point, just the x value of the turning point, because that will tell us where this graph will be at a minimum. Okay, so to find the x value belonging to that turning point, all you have to do is, you see, this is your x-intercept and this is another x-intercept of this graph. That point that we're looking for is going to be exactly in between, halfway in between these 2 points. So we're really going to find the midpoint of these 2 points. And how we can find that is, first of all, it's already on the x-axis. So we already know that it's going to also be on the x-axis. We just need to find its x value. And you can find its x value by using this part of the midpoint formula. We're just going to say x1 plus x2 and divided by 2. So we're taking x1 of this parabola's x-intercept, okay, because it's halfway between these two x-intercepts of the parabola. So we're taking the negative 3.4 and adding it to the 0.7, and then you're going to divide that by 2. That will be the calculation. And so if we do that, let's see what we get. So if we do that, we get negative 1.3. So that is the amount we get, negative 1.35. Okay, so that point where x is equal to negative 1.35, that will be where this graph will be at a minimum. And therefore, that is where the gradient of a tangent to this graph will be a minimum. That will be your answer. Okay, so we need all these calculations there. Okay, and that's how we find the answer. Okay, so that's a way to really just understand what was actually going on there. Okay, so moving on to the next question, this is what we have. We have f prime of x being multiplied by f double prime of x. Where is it going to be less than or equal to 0? Okay, let's talk about this graph, f double prime of x. Since f prime of x, we already found that it's a parabola. So remember, this is how it works. The cubic function, that was f. If you derive this positive cubic function, it will give you a concave up parabola. Okay, also just remember, if your cubic function, if a was less than 0, it would not look like this. It would be like an n, a capital letter N, written backwards, like that. And if you derive that kind of graph, you would have a concave down parabola. Okay, so in this one, we have a concave up parabola for f prime of x. So f double prime of x will be a straight line, but an increasing straight line. So that is a straight line with a positive gradient. So I'm just showing you what f double prime of x is going to look like. We're going to have to draw this in order to be able to find out what x is going to be for this. Okay, so let's start off with drawing it. Remember, it is an increasing graph like that, but there's also something else we know about it. This graph, so we have the parabola, right? And we know what the x value belonging to the turning point of the parabola is. So the thing about that f double prime of x, this graph, you see its x-intercept. It's going to have the same x value as the x value of your parabola in the f prime of x. Okay, so these are just stuff that would be in textbooks that you have to study first to remember. So we can go ahead and draw this straight line graph. So that graph, the f double prime of x, is going to be a straight line, and its x-intercept is going to be that negative 1.35 that we found. So I'm actually going to put that point down so that we don't forget. That's that negative 1.35. Then the x-intercept is going to just be a line that will pass that point on the x-axis. Okay, so this is what this graph is going to look like. F double prime of x is going to be a straight line that is increasing because the parabola is concave up, and its x-intercept is going to be that negative 1.35, which is also the x value of your parabola's turning point. Okay, so the question there, so now that we have that graph drawn down, let's figure out what they want. They want where f prime of x multiplied by f double prime of x gives us something less than or equal to 0. Okay, so if I'm going to actually put them in their colors, remember that this graph was pink and that one was blue. Okay, so to find this, really what we're looking for is this. So we're saying when we multiply, and just remember when we're saying f prime of x, it refers to the y values of this graph and the y values of this graph. So this is the parabola and this is the straight line. Where do you take the y values of this and you multiply to the y values of that, and it gives you something less than or equal to 0? This is only possible if the y values of this graph is positive, and we multiply it by the y values of this graph, which would be negative. Then you would get something that is less than 0. Okay, so I'm speaking about the less than 0 first. We will also look at the equal to 0. Now, another way this could have happened is if the y values of this graph was negative, and we multiplied it by the y values of this graph, which was positive, then we would also get something that would be less than 0 or negative. That's what less than 0 would refer to. But we also have to watch out for where we will multiply these values and they would give us 0. Okay, this will only be possible if, for example, the y values of that was 0 multiplied by the y values of this one, and let's say that was either positive or negative. It doesn't matter, because if you multiply 0 by either a positive or negative number, you're still going to end up with 0. Okay, so that would be the equal to 0 part. We could also have a situation where this graph could either have positive or negative values and multiply by this graph, which has a value of 0, a y value of 0, then we would also get 0. So this is really what we are looking for on the graph, and you'll see how we're going to try and find it. Okay, so here's the graph. I've decided to put the requirements here on this side. So we are going to concentrate on f prime of x and f double prime of x. So just the pink and the blue graph. And since this is the last graph, I know that you're supposed to still, of course, have that cubic function, but just to avoid any confusions, I'm going to erase the cubic function. And let's just work with it like this, because this will just make more sense. Now we can just focus only on these ones. Okay, so this is what this graph looks like now. So I'm erasing everything about the cubic function because I don't really see a need of leaving this here, since that is the last question. Okay, so that is the last question for this section. Okay, so this is what we can do here. So first we're looking for where are the y values of the pink graph going to be positive. The y values are positive here. So remember, this is the y-axis. This is the positive part of the y-axis. That's the negative part. So notice the negative part is below the x-axis. The positive part is above the x-axis. So you're only going to look for parts of the pink graph that lies above the x-axis, since we're looking for where that is positive. And the parts of the pink graph that lie above the x-axis would be here. So here, that is above the x-axis. But we need to find at the same time, okay, for the same x values, the blue graph needs to also be negative, okay? So it needs to be for the same x values. So I notice that it starts becoming positive here after this point. So when we go like to the left of this point, you see that these have positive y values. Okay, the pink graph has positive y values. If I look at that, the blue graph for this same x values, I will also have to I will look at it in a vertical line like that, because this point on the blue graph, the x value is exactly here, is also negative 3.4. So if these are the points that belong to the highlighted part of the graph, so these x values, let's also see where they belong to on this blue graph. These same x values, if you extend this down, look at where it is. You see this blue graph has a negative y value. And for the same x value, the pink graph has a positive y value. And that's what we want. We want where the pink graphs have positive y values, and at the same time, or for the same x values, the blue graphs have negative y values. And this is happening over here. So you see here, same x value at this point over here, it has a positive y value. And if you look at it for the same x values for the blue graph, it has a negative y value. That's what we're looking for. So you see it happens all the way here. So let's mark this point. Now, the reason I cannot take beyond this is because of this. If you go beyond this, you see the blue graph? Yeah, it has negative y values. But the pink graph at those specific points, at that same x value, you see it doesn't have a positive y value. The pink graph has a negative y value here. And for the same x value, the blue graph has a negative. That's not what we're looking for. We're not looking for where the pink is negative and the blue is negative. The pink graph needs to have positive y values. So we cannot take anything that goes past this line here. Meaning these x values are only values that are less than negative 3.4, because you see they are moving to the left of negative 3.4. There's nothing on the right. It's not working on the right here. Okay, so that's the first solution we have. We can go ahead and say this one, that part worked where x was less than negative 3.4. Okay, now we cannot just assume that this is the only place that it happened. We also have to check through the rest of the graph. So if we look on this part of the graph, and the reason I'm choosing this wing is because I want where the pink graph has positive y values, meaning it needs to be above the x-axis. Here it has positive y values. Here it does not have positive y values. That is below the x-axis. So I'm taking only this part of this graph. Let me see. Does the blue graph for the same x values also have negative y values? So if you look at that, you see this part of the graph. I'm trying to see, okay, let me line this up vertically to the blue graph as well. If we start moving towards this side where this graph is positive, where it has positive y values, move in the same direction for the blue graph, you see that this blue graph has positive y values as well. So that's not going to work. We cannot have where the pink graph has positive y values and the blue graph has positive, because that's not the requirement. The blue needs to have negative. So it's not working anywhere else here. Okay, so it just means that this first requirement has been met, where this is positive and this is negative. That works out. Okay, and it only works here for now. Now, let's also consider the zeros, because that's also important. Remember, we are also looking for places where if you take the y value of this one and you multiply to that, it gives you 0. Meaning this graph, if its y value is 0, which is here at the x-axis, okay, at this x-intercept, this pink graph has a y value of 0. If you multiply it to the y value at the same x value, okay, of the blue graph, it should give you a 0, because 0 multiplied by this y value, which is negative, will give you 0. So it means that in this case, negative 3.4 is also an included point. So I can't just say x is just smaller than negative 3.4. It's smaller or equal to negative 3.4 because of that equal to 0 as well. Okay, so it's really just multiplying the y values of the graph. The pink graph's y value is 0. If you multiply it by the blue graph's y value at that same x value, the blue graph's y value is negative. So 0 multiplied by whatever negative number that is will give you 0. So that's why I have to say this here. Okay, so that means all through I didn't really find any other place that it worked. Okay, so long we are done with that first requirement. Now let's look for where the y values of this pink graph is going to be negative and the y values of the straight line graph will be positive. Okay, so where are the y values of the pink graph negative? That happens below the x-axis. Now the thing is, at the same time, the y values of the straight line graph must be positive. So I'm only going to look for those places. So over here, this part, the reason I will not take this is because, yes, this part may have y values that are negative. But you also have to look at the y values of this straight line. So you see over here, like just a point over here, it has a negative y value on the pink graph. But on the blue graph, that same point for the same x value, it has a negative. So I cannot take that. Okay, because that's negative and negative. I need to look for negative and positive. So if I keep going on this graph, you see that as you keep going like downwards, moving from left to right, it's still negative all through here. But this graph as well is also still having negative y values. So I keep moving down. I even get to here and I see I still have a negative y value here. But for the same x value, this graph also needs to be positive. Okay, but it's negative. So it's not working until we get here to this point. You see, at this point, this y value of this graph is 0. So the y value of the blue graph is 0. And if you multiply it by the y value of this graph, okay, the pink graph, it's a negative number. And if you multiply those y values, they give you 0. So since this is one of the requirements, I have to take this. So I have to take this point where x is equal to negative 3.5. But before taking it, let me just check if we also meet one of these requirements, this one, the negative and the positive. So over here, you see that this graph has negative y values, negative, negative, and all of that. But for the same x values, this graph needs to have positive y values, which you can see is working here. A negative y value for the pink graph. And if you line it up to the x-axis and past that, you see that this graph has a positive y value. So it starts to happen from this point, negative 3.5, moving towards the right. It keeps working, okay, until this point here. Because now, here we still have the pink graph having a negative y value and the blue graph having a positive y value, which is what we're looking for, until you get to this point over here. So when we reach this point, you see that the pink graph's y value is 0 because this is an x-intercept. And the blue graph's y value is going to be positive. So if you take that 0 multiplied by whatever positive number that is, that will be 0, which is one of the requirements. When we multiply the y values, we should also get 0. So it means that it's working everywhere in between here. So it means that x is either greater than, so it's moving towards this side, or equal to negative 1.35, but less than or equal to, I also have to say equal to 0.7. Okay, so that is what we have there. These would be our two solutions. Okay, so we're saying it's either that x is less than or equal to the negative 3.4 or x is greater than or equal to negative 1.35 but less than or equal to 0.7. Okay, so this is our answer for this. So that is it for question 8, and then we move on to question 9. Okay, question 9. So question 9 says a wire 12 meters long is cut in 2 pieces. One part is bent to form an equilateral triangle and the other a square. Okay, so an equilateral triangle, all the sides are equal. A side of the triangle has a length of 2x meters. And 9.1, they want you to write down the length of a side of the square in terms of x. Okay, so since they say a wire which is 12 meters long, okay, so 12 meters long, we have this wire. and the full length of it is 12 meters. But then they say it's cut into two pieces, so not half, just two pieces, and one part is bent to form an equilateral triangle. Okay, so since this line is being cut into two parts, I'm going to just call it like it's being cut into two parts. I'll call this part A and I'll call this part B. So, okay, it's cut into two parts and then one part of it is bent to form an equilateral triangle. So let's say that was the part A that was bent to form an equilateral triangle. So out of that, we form an equilateral triangle, just knowing that all the sides in this triangle are equal. And then they say, and the other a square. So the other part is bent to form a square. So that would be the length of B. Okay, so I'm going to go ahead and draw a square, and that is B. And in a square, all the sides are equal. Okay, then they say that a side of the triangle has a length of 2x meters. So one of the sides has 2x meters. So it means everything else is also 2x meters because all the sides of a triangle are equal. So the whole point of this is to write down a side of the square in terms of x. So we need to find one of these sides, but it needs to be in terms of x. Okay, since it needs to be in terms of x and the only thing that has x in it is the triangle, we start from here. So since this entire wire, everything here, right, is made up of this one part, which I've called A. It's made up of that one part. So let's find the formula for A. So we can say that A, the value of A, that length of that wire, can be the entire 12 meters minus the length of B. So that is 12 minus the B. Okay, so that's what A is. So since A is the entire wire, let's put it in terms of x. Since all of these lines are equal, these sides are equal, it means this is 2x and this is also 2x. So if we're calculating the length of the entire wire in terms of x of this triangle, it's going to be the 2x plus the 2x plus the 2x, which would give you a 6x. So that's the length of A. That is that piece of wire, that's A. So I can say that 6x is equal to 12 minus B. So because I want to name this one in terms of x, it would not make sense to try and make x the subject here. Rather, I'm going to make B the subject, and then I'll be able to name that in terms of x, since the entire length of this part is B, and that's what is used to make the square. So we can take B over to the left-hand side and it becomes positive. It's equal to, and we still have the 12 here, and we're taking the 6x over, so minus the 6x. Okay, so B is equal to 12 minus 6x. But B happens to be the entire length of this square. Okay, so I'm saying that B is the entire length of this square. So that is that 12 minus 6x. Okay, that is everything here. And since each side, all the sides in the square are equal, to just find one of the sides, if this is the entire length of it, I just have to divide this entire length by 4, and it will give me the length of one of the sides of this square. In a way, we can look at it like this. Since B is the entire length of this wire and it's the entire length of this square, that's like looking at the perimeter of the square. And the formula for perimeter of a square would be 4 multiplied by s. Because whatever the side is, you just multiply that by 4 and that will give you the entire perimeter, since all the sides are equal and there are 4 sides. So if 4s is equal to 12 minus 6x, remember we just want to find the length of a side. We just want to find s, one of the sides of the square. So we can divide both sides of the equation by 4 to find s. And so one of the sides of this square would be this. So I'll just divide. 12 divided by 4 is 3. Negative 6 divided by 4. So if you say negative 6 over 4, it simplifies to, I'll leave it as a fraction, minus 3 over 2. And we have x as well. Okay, so that is one of the sides of this square in terms of x. So it means that one of the side is equal to 3 minus 3 over 2x. Okay, so that's the first question. Moving on to the next question. Then question 9.2 says, if the square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Okay, so we have to find the maximum volume. Okay, so if this square is going to be used as the base of a rectangular prism. Remember, rectangular prism kind of looks something like this. Okay, so it can be something like this, a rectangular prism. And so they're saying that the square is now being used as a base of the rectangular prism. So the square that we had, one of the sides of it, so each side is equal to 3 minus 3 over 2x. So it means that this as well would also be like that. We have all the sides being equal because the base is a square, and one of the sides is just 3 minus 3 over 2x. Then they also tell us about the height. Okay, they tell us that the height of this rectangular prism is 4x meters. So you can kind of imagine it as if it's standing up. This part over here would be the height of it. That's how high it is. So that is 4x meters. Okay, so we have to determine the maximum volume of the rectangular prism. To find the volume of it, the formula for volume is equal to, of a prism, would be the area of the base multiplied by the height. That's how you'll be able to find out how much space is filled up in this entire object. So the area of the base, remember the base is a square. To find the area of a square, you just say the side multiplied by the side, which is really just side squared. And then we have to say that's the area of the base parts, then multiply by the height. We know that one side is equal to 3 minus 3 over 2x. So we have that 3 minus 3 over 2x, and that side needs to be squared, so all squared. And then we'll multiply that by the height, which is 4x. So multiply by 4x. Okay, so this would be the volume. Then we still have to find the maximum volume after that. So let's go ahead and find just the equation of the volume of this. So to simplify this, remember this is a binomial being squared. Just square the first term. That's going to give you 9. Then you multiply the first term by the second term. So that is 3 multiplied by negative 3 over 2. So negative 3 over 2. Then you see that answer that you get, you're going to take that and multiply it by 2. Okay, you could do it the usual way of creating two brackets and foiling out, but that takes long. So then that will give you a negative 9x. Okay, because when we multiply this times this, that becomes that negative 3 over 2x. Then when you multiply by 2, it becomes a negative 9x. Then lastly, you square the last term. So if you take this and you square it, first of all, it's going to become positive. Then the 3 is going to be squared and give you 9 over the 2 being squared gives you 4. And the x being squared gives you x squared. And all of this is being multiplied. Okay, so multiplied by 4x. We multiply by 4x. Okay, so I'm just going to rewrite it like this instead. So I'm writing the 4x in front because since it's only one term and it's being multiplied by all of this by, let me put it in the order of its exponents. Since this has x squared, I'm going to write it first. So I'm going to say it's a positive 9 over 4x squared. And then we have the negative 9x. And then we have the plus 9. Okay, so this is going to multiply in. So we're multiplying these in. And what we're going to get is, you can use the calculator here just to be careful. So 4 multiplied by the 9 over 4. So 9 over 4x squared, it gives us a 9. So we have 9. And this x times the x gives you x cubed. Then it's the 4x multiplied by the negative 9x. So what is 4x multiplied by negative 9? Okay, negative 36. And so x times x will give you x squared. Then we have, again, a 4x multiplied by a positive 9. That will be positive 36x. Okay, so this is the formula for the volume of this shape. But now we just have to find out, they ask for the maximum volume itself. So they're not just asking for you to determine the value of x for which is going to be a maximum. They want the maximum volume. So first we're going to find out at which x value will this have a maximum, okay, volume. So let's go ahead and do that. And the way we'll do that is just remember that looking at the way this formula looks, it has 9x cubed. This is going to be a cubic function. And the coefficient of x cubed is 9. So that is a positive number, meaning your graph is going to look like that, something like that. Okay. And so we can go ahead and find what we're trying to find is the maximum value itself. So it has a local maximum and a local minimum. We're looking for this one, the local maximum, and specifically its y value. So let's find its x value first. So since this is the formula of it, to find that y maximum, that maximum value, since it's a turning point, we're going to derive this so that we're really finding the gradient, okay? So the gradient of this graph, but specifically where the gradient is equal to 0, because the gradient is always equal to 0 at the turning point. So let's derive this. 9 times 3, so 9 multiplied by 3, that gives you 27. So 27x, and then take out a 1 from the 3 squared. Then negative 36 times 2, that is negative 72x. And so take out a 1 from that, it gives you 1, but we don't have to write that. Then plus 36, and that x falls away because it becomes a 1. So this is the gradient of this function that we had, the volume of that. Now we just have to make that gradient equal to 0 because that will help us to find the turning points. Only at the turning points are the gradients equal to 0. So we have 27x squared minus 72x plus 36. Then, if we look at all these numbers, we have to factorize this. All of these numbers, let's just see what can go into everything here. So 27 divided by 3, okay, is 9. 72 divided by 3 is 24. 9 and 24 already have something in common. They have 3 in common, so it means there's a bigger factor we can divide by. Let's try 27 divided by 9. Okay, it's 3. 72 divided by 9. It's 8. Okay, so I know 3 and 8 have nothing in common. So, okay, so that means we can divide both sides by 9. 9 can definitely go into all these numbers. So if we have 0 is equal to 27x squared divided by 9, that is 3x squared. 72 divided by 9, that's minus 8x. And then 36 divided by 9, I think that's 4. 36 divided by 9, yeah, okay. So positive 4. Okay, so that's what we have. Okay, then you have to factorize this. So I'm going to use the factorizing method. You can use the quadratic formula if you want to. So we're going to open up 2 brackets, and because there's a coefficient here, you cannot factorize it normally. I'm going to use the cross method. So I'm saying 3x and x, and then I need, so that's the factors of 3x squared. Then I need factors of 4, but once that will help me get an 8 in the middle. The fact that the middle is the only negative one, you should know already that both terms will be negative. Okay, so I have a negative and a negative. I would have tried 4 and 1, but this doesn't seem to help to give an 8 in the middle, because that will give you negative 3, and that's negative 4, and that's negative 7. That doesn't give you negative 8. So I'm going to try 2 and 2. Okay, so 3x multiplied by negative 2, that's negative 6x. And then x multiplied by negative 2, that is negative 2x. Okay, so that gives you negative 6x minus 2x, negative 8x. And that is the middle term. So these are our factors. It's 3x minus 2 and x minus 2. Okay, so that's what we have. So solving for x, we're saying 3x minus 2 is equal to 0. Or we have x minus 2 being equal to 0. 3x is equal to, take the negative 2 over, divide both sides by 3, and x is equal to 2 over 3. Or it is where x is equal to taking that over 2. Okay, so we have 2 solutions here, and we have to now decide which one is going to be the one that belongs to the maximum turning point. The way you can decide that is knowing the shape of your graph. Okay, the shape of our graph looks like this because it's a cubic function and a is positive. So since it looks like this, then it means that this here is your maximum. And if you're looking at this on a Cartesian plane, then it would mean that the x value belonging to the maximum is the smaller x value. So we have to take this one, this 2 over 3. That would be the maximum. And then the bigger x value is 2. That would be the minimum, the local minimum. Okay, so we know it's this one. So since x is equal to 2 over 3, to find the actual maximum, okay, that maximum volume, you're going to take this x value, belonging to that maximum y value and substitute it into the original equation of this cubic function so that you can find out what that y value is. So the original equation is this volume right here. So we're taking the original equation and we're going to substitute 2 over 3 because it's the x value that belongs to that maximum y value. So v, and we're subbing 2 over 3 in there, is equal to 9 bracket 2 over 3 all cubed minus 36 open bracket 2 over 3 all squared plus 36 open bracket 2 over 3. And you can go ahead and put this onto the calculator and let's see what we get. And the answer we get is that 32 over 3. But because it's volume, I'm not going to really call it just 32 over 3. I'll put it in decimal form and round off to 2 decimals. So it is this 10.66. So we can just round off to 2 decimals. That volume of that is going to be 10.67. And because it's in volume, okay, it's going to be meters cubed. Remember, these dimensions were in meters. So that is 10.67 meters cubed. That is the maximum. So you can conclude and say the maximum volume is that answer, okay, of the rectangular prism. So the maximum volume of the rectangular prism is 10.67 meters cubed. And that is our final answer in question 10. And so moving on now to question 10, which is the last question in the paper on probability. Okay, now we are on the last question of this paper, question 10. And 10.1 says, a group of people participated in a trial to test a new headache pill. 50% of the participants received a headache pill. Then 50% of the participants received a sugar pill. Then 2 out of 5 receiving the headache pill were not cured. Okay, so out of the headache not cured was 2 out of 5. They received the headache pill. And then 3 out of 10 of the group receiving the sugar pill were cured. Okay, so the first question, they want us to represent the given information on a tree diagram. Indicate on your diagram the probability associated with each branch as well as the outcomes. So they just want you to draw the entire tree diagram. Okay, so this study, we have a group of people and they're testing a new headache pill. 50% received a headache pill, 50% received a sugar pill. Okay, so headache pill and sugar pill. Those are the two branches that we have first. So I just call this one HP for headache pill and SP for sugar pill. So 50%, that is a half as a fraction. They got the headache pill and a half of that group got the sugar pill. Then they're saying 2 out of 5 of the group of people receiving the headache pill were not cured. So out of these people receiving headache pills, there were people who were not cured. Okay, so it means that we have two criteria as well. You can either get cured or not cured. So I'm going to put not cured, okay, NC. That was the 2 out of 5 people. Then they also tell us that 3 out of 10 of the people receiving the sugar pill were cured. So I can't put that here. That's headache pill. The people who got the sugar pill, 3 out of 10 of them were cured. So I would just put 1. This branch is for not cured. But the ones that were cured was 3 out of 10. So it means that we can just find these ones. We can find here in the people who took the headache pill, we can find the people who were cured. Okay, and the amount of people that will be cured, not really the amount, just the fraction of people. If 2 out of 5 people were not cured, then it means that 3 out of 5 people were cured. So that when you add them, they make up 5 out of 5 people. Okay, so here, the people who were not cured, if 3 out of 10 people were cured, then it means that 7 out of 10 people were not cured. This would be your tree diagram and all the probabilities associated with the branches as well. Okay, so they say indicate you have to show the probability associated with each branch. So like, for example, headache pill, it's half. Or from the headache pill, the people who were cured, it's 3 out of 5. Those will be the probabilities associated with each branch. But then they also say as well as the outcomes. So I guess we also have to show those outcomes on the side. Okay, you might hear some background sound, but it's because it's raining. Please excuse the background sound. Okay, so I'm going to put the outcomes as well on this side. Okay, so the first outcome, we're looking at the probability of people who received the headache pill and were not cured. Okay, so we're looking for people who received headache pill and were not cured. And that would be, you would have to take that half and multiply it by the 2 over 5. Okay, and that would be equal to, okay, that's going to be 1 over 5 because you can see that the 2 and 2's will cancel. So 1 over 5. And then we have to look at the people who received the headache pill and were cured. So headache pill and cured. And so we're going to take that half and multiply it by the 3 over 5. So 3 over 5. Let me see if I can guess this one. It's going to be 3 over 10. Okay, so no need to put it on the calculator. Okay, so this is going to be 1 times 3, that is 3, over 2 times 5, that is 10. Okay, then we're going to look at people. So we're done with the people who took the headache pill. Then the people who took sugar pill. So sugar pill and were not cured. So the sugar pill and not cured. And that would be a half multiplied by 7 out of 10. Okay, to multiply this, I'm just going to cancel. No, I can't cancel. 1 times 7 is 7 over 20. Okay, then the people who took the sugar pill and were cured. So, and cured, that would be the half multiplied by the 3 out of 10, which is equal to 3 over 20. Okay, so those would be the outcomes of everything as well. So that is for 3 marks. Yeah, that looks like a lot of work for 3 marks. But okay, moving on. And then question 10.1.2, next question says, determine the probability that a person chosen at random from the group will not be cured. So whether they took the sugar pill or they took the headache pill, we just want the probability of people who will not be cured. So that's what we're going to be looking for. As long as they were not cured, you're going to take that. So looking at the outcomes, look at what we're going to take. We're going to have to take that. These are people who took the headache pill and were not cured. And we're going to have to take this. This would be people who took the sugar pill and were not cured. We have to take both of these because these people, regardless of whatever pill they took, they were not cured. That's what they asked for, people who were not cured. Okay, so this is really how we're looking at it. In other words, if we just use words to say it, we're looking for people who were not cured. So they can either be people who took the headache pill and were not cured, or it could be people who took the sugar pill and were not cured. Notice the word or was used. When we say or, it means to add. And you can look at it like this. Let's say we have a coin and this coin has a head and tails. So if I say, what is the probability that you're going to flip this coin and land on heads? Then since it's a coin, it's just going to be 1 out of 2 because there's 1 head out of the 2 faces that are on this coin. But if I said, what is the probability that you're going to get heads or tails? That's going to land on heads or tails. You're only going to ever land on either heads or tails. So it's 100% chance. And the reason why is because we said the half plus the half. And that gave you 2 over 2, which is 1 or 100%. Okay, so that's why when you see the word or, you need to add. So we're looking at the probability of people who took the headache pill and were not cured. And we adding that, okay, to the people who took the sugar pill and were not cured. Okay, and we already have these numbers. So the people who took the headache pill and not cured, that is 1 out of 5 in total when we multiply headache pill and not cured. So 1 out of 5 plus 7 out of 20. So 7 over 20 plus 7 over 20. And let's see what we get. And if you put that on the calculator, then it gives you 11 over 20. Okay, so that's that answer there. And moving on to the next question. So question 10.2, we have 3 events A, B, and C are considered. Probability of A is 2 over 5, the probability of B is 1 over 4, and the probability of A or B is 13 over 20. So 10.2.1 says, Are events A and B mutually exclusive? Support your answer with the necessary calculations. So they want to know if they are mutually exclusive. So the thing about mutually exclusive events, since they're speaking about A and B, for events to be mutually exclusive, then the probability of A and B would be equal to 0. And this really just means that there is no intersection, because remember, mutually exclusive events, they do not intersect. So in a Venn diagram, they look like this. No intersection. So let's think about a formula that we can have that will include A and B. So where we can actually solve for A and B. They told us about the probability of A or B. The formula for this, the probability of A or B, is equal to the probability of A plus the probability of B minus the probability of A and B. So as you can see, we have this now. We have the probability of A and B. So let's go ahead and put down what we have. Probability of A or B is 13 over 20 is equal to the probability of, I think I can write that smaller, 13 over 20 is equal to the probability of A, which is 2 over 5, plus the probability of B, which is 1 over 4, minus the probability of A and B. Okay, so in this, I'm going to take this over just to make it positive. It's negative right now, but if we put it over the equal to sign, it will be positive. So now that is the probability of A and B. Okay, it's negative because of the minus in front of it. And it's equal to, if we add these two together, so 2 over 5 and then plus 1 over 4, that gives us 13 over 20. So this is equal to just 13 over 20. And then, remember, that's just this part. Then we also have a 13 over 20 here. We can take that over and that becomes a minus 13 over 20. So it really just means now that the probability of A and B is going to be equal to 0. And there we go. So if the probability of A and B is equal to 0, then it means that A and B are mutually exclusive. Okay, so it would mean that those events are mutually exclusive. So mutually exclusive events. Okay, so that is the first one. We've proven that they are mutually exclusive. The next question says, determine the probability of only C if it is further given that the probability of A or C is 7 over 10, probability of A and C is 2 over 5, and 2 times the probability of B and C is equal to the probability of A and C. Okay, so there's a lot of information they give us here, and for us to know how we need to use it, let's focus on what we actually need to do. We need to find out what the probability of only C is. That's the goal. So let's focus on that. How can we find the probability of only C? Well, a good way to be able to look at this information is by looking at it in a Venn diagram. So the good thing about this, we already know what the probability of A is, we know the probability of B is, and we even know that A and B are mutually exclusive. So as you can see, they're only mentioning 3 events. We have A, B, and we have C. We know that the circle of A and the circle of B will not intersect because they are mutually exclusive events. So they'll look something like that. But now let's see if A and C are going to intersect. Notice they say that the probability of A and C is 2 over 5. Meaning there is an intersection between the circle of A and the circle of C. But then they also say 2 times the probability of B and C is equal to the probability of A and C. And you see that the probability of A and C has a number. So since we can see there's also an intersection here with the probability of B and C, it means that the circle of C also intersects with B. So the circle of C kind of looks like this. So it's a circle that will intersect with B and A because it has intersections with them. Okay, so that's what this looks like. Now, what they want us to find is the probability of only C, meaning not the entire circle of C, but just only C. You see, if you take the entire circle of C, if you take everything in here, notice that that will include that little part, but that is part of A. We cannot take A, anything in A. And if we take this entire circle, it will also include this little part, which is part of B. We need to take the ones that is only C. So we're only going to take these ones. We're going to take this part, excluding those little pieces. So excluding those intersections. Okay, so how can we actually find out this? What is a formula, an equation that we can construct to find out what this is? Well, we have the circle of C. We can focus on the fact that we have the entire circle of C. If we could find out, so I want the probability of only C. If we could find out what the entire probability of C is, the probability of C is, and then we subtract that by this intersection over here, that is the probability of A and C. And then we also subtract that by this circle here, the probability of B and C. Then it will leave us with the probability of only C, that shaded part in purple. Okay, so let's go ahead and do that. So we're going to look for the probability of C. Let's see if we have that. So notice they don't really tell us the probability of C, although they do mention things that have the probability of C in them. They tell us about the probability of A or C, and they also tell us about the probability of A and C. So we can use the OR rules formula to actually find this one by saying the probability of A or C is equal to the probability of A plus the probability of C, then minus the probability of A and C. Okay, so let's look at what we have. So remember, the whole goal of this is to find this, the probability of C. So the probability of A or C, that is equal to 7 over 10. So we can say 7 over 10 is equal to the probability of A, because we need to add that now. Probability of A, we have that. They said the probability of A was 2 over 5. So that is 2 over 5 plus the probability of C, that's what we're looking for, then minus the probability of A and C, which they told us is 2 over 5. So that is 2 over 5. Okay, so looking at this equation, you can see that we have 2 over 5 minus 2 over 5, and so those would cancel. And now we have the probability of C is finally just equal to 7 over 10. Okay, so now we have the probability of C, we have this one. Now let's look for the probability of A and C. Well, we have that. They already told us that was 2 over 5. So we have the probability of A and C. So lastly, we need to find the probability of B and C. Okay, so they told us something about B and C. They told us that 2 times the probability of B and C is equal to the probability of A and C. So let's go ahead and use that equation. Okay, I'm also just going to move everything up to here. Okay, so looking for this one. So let's use that formula. We know 2 times the probability of B and C was equal to the probability of A and C. But we already know what the probability of A and C is. That is 2 over 5. So it's equal to 2 over 5. So we just have to solve for the probability of B and C by getting rid of this 2. And so we'll just divide both sides of the equation by 2. And so that means the probability of B and C would be equal to this 2 over 5. And then we can just say divided by 2. And so that gives us 1 over 5. So 1 over 5 as the probability of B and C. So now we have the probability of B and C. We have everything we need to find the probability of only C. So I'm going to rewrite this formula and let's just substitute where we need to. Okay, so let's see, the probability of only C would be equal to the probability of C, which is the 7 over 10 that we have. So 7 over 10 minus the probability of A and C, which we also have that. Probability of A and C, that was the 2 over 5. Okay, so the 2 over 5, and then minus the probability of B and C, which is 1 over 5. So let's go ahead and see what we get. Okay, so this is what we get. We get 1 over 10. So 1 over 10, that is the probability of only C. Okay, so you see ways that you can find these answers. You're going to have to construct equations. Don't get lost or confused by the amount of information they put. Just try to think in the direction of, let me construct a way to find this answer. And so you will start to see that the information that they put down are actually things that you need to get to your answer. Okay, so the next question we have is this. They ask us to determine the probability that events A, B, or C do not occur or take place. Okay, so how do we find the probability that they will not take place? Okay, so to explain this, let me bring this Venn diagram back down. So look at what they're asking for. They want the probability that event A, B, or C do not take place. So none of them must take place. This is how you can look at it. We don't want A, we don't want B, we don't want C. So if you look at that, what is remaining in this Venn diagram? It is whatever is outside the Venn diagram. So it's that event where they are neither A nor B nor C. And I'm going to go ahead and just call that X. And now how do we actually find this value of X? Well, if you look at a Venn diagram, all the events in the Venn diagram, remember that they are giving us these probabilities as fractions, right? So if they're giving it to us as fractions, everything in the Venn diagram, when you add it up, it will add up to 1. It's like one whole. In other words, 100%. So it's 100% of all the data in this study, in this Venn diagram. So in order to find X, we're going to find X by actually saying it would be equal to 1 minus the probability of A or B or C. Okay, that's how we're going to find it. And so from this, you can already see now that all we need to find is what is the probability of A or B or C. So this is how we'd find the probability of A or B or C. We're going to take the entire circle of A. So remember that the word or means to add. So we're adding all these probabilities together. We're taking the entire circle of A and we're going to add that to the entire circle of B. But let's start with C just so that you can see what's going on here. We're adding that to the entire circle of C. But then look at the problem here. You took everything that was inside the circle of A, right? Including that little piece, that intersection. That's included in the circle of A. And then you added it to the circle of C. Also includes that intersection as well. Now, you see the problem with that is that you just added that intersection twice. And this is the reason why in the OR rule, when we take the probability of A or C, for example, we say the entire circle of A plus the entire circle of C, and then we have to say minus that intersection. It's not because we're trying to remove the intersection, it's because you added the intersection twice. When you said the entire circle of A, it includes the intersection, plus the entire circle of C, it includes the intersection as well. And so you see that is added twice, and that's why we have to say minus the probability of A and C. That's what that rule is meant to do. Okay, so when we're actually finding this, we're just trying to find the probability of A or B or C. I'm going to just sum it up all together here. So that is going to be made up of the probability of A plus the probability of C. Then, of course, you have the minus the intersection, but I'm going to do that at the end. Then we also have to add the probability of B as well. Now, you see, the problem with this is if I add the probability of B, when I spoke about the entire circle of C, that included that intersection by B. So if I add again the entire probability of B, that is also included that intersection. That's why I also have to say minus the probability of B and C as well. Okay, so I will add the probability of B, but then now I need to remove those intersections that have been added twice. So minus the probability of the A and C. So A and C, and then minus this one that has been added twice as well. So minus the probability of B and C. And that would give us the entire probability of A, B, and C, all of those circles. So you see in this, I don't have to say minus the probability of A and B because there is no intersection between those two circles. Okay, so let's go ahead and see, do we actually have this? And they didn't really give us more information, so it means everything is probably here. So it's equal to the probability of A. We have that. They told us that and in the beginning. So probability of A was 2 over 5. We have that. So we can just say that is 2 over 5. Then plus the probability of C. The probability of C, we also have that. We actually had to find that. Probability of C is 7 over 10. So that is 7 over 10. Then plus the probability of B. The probability of B, do we have that? Yes, we had that from the beginning. So probability of B, that's 1 over 4. So 1 over 4. Then we have to say minus the probability of A and C, which That one, I think that was 2 over 5 we had. Yes, 2 over 5 probability of A and C. So minus 2 over 5. And then lastly, minus the probability of B and C, which we simplified. Yes, that probability is 1 over 5. So minus 1 over 5. And let's go ahead and see what that is going to give us. And we get a 3 over 4 as the probability of A or B or C. Then remember to find the probability of not A or B or C, that is that X over there. So that would be equal to 1 minus the probability of all of that A or B or C, which we now know is 3 over 4. So minus 3 over 4. So that would be equal to, it's probably going to be a 1 over 4. So it's like 4 over 4 minus 3 over 4, 1 over 4. So you can answer them in a way that what you're saying is actually written properly, kind of like written in the correct notation. So I'm just going to say it's the probability of A, not A, I mean, or not B, or not C. So it's like the complement of it is equal to 1 over 4. Okay, so that's our final answer there. Then moving on to the next question. And now we're on question 10.3. And question 10.3 says 7 friends, which is made up of 4 boys and 3 girls, want to stand in a straight line next to each other to take a photo. 10.3.1. How many ways can the 3 girls stand next to each other in the photo? Okay, so the 3 girls need to stand next to each other in the photo. Okay, so I'm just going to make these symbols. For the boys, I'm going to put that, and for the girls, I'm going to put that. So let's represent these 7 friends. These are the 7 friends, and the question is asking in how many ways can the 3 girls stand next to each other in the photo. So notice that a group has been created here. When we create groups in the counting principles, this is what we're doing. We're making these one group. So no matter where they stand, they need to be just one group on their own. They need to always stay together. This is what I mean by that. So, for example, this is what I mean by that. You see this one boy, he could be standing here on the right of them. We could even have a case where 2 boys maybe stand on the right of them. As long as these 3 girls are together, we have created this one group. And this is how I like to work with groups. So I'm saying that these 3 girls are together. They don't necessarily have to be at the back. They can also be at the front. So if they have to be in one group together, we're going to look at it like this. I'm going to say the amount of ways that these 3 girls on their own can stand like this, because remember, there are 3 different girls. Yes, they're standing together, but this first girl doesn't have to be standing only in this position. She could also stand in the second position or the third position. The second girl, after the first one is standing, she has 2 positions to stand at. And the last girl can also just stand in this last position. So to find out the amount of ways that they can be seated, even though they are sitting together right now, we would have to say 3 factorial for that. So that's just for inside that group. They don't have to be sitting in this order. Okay, then the rest. Remember, they didn't say that the boys have to be seated together. And that's why I said that the boys, for example, this one boy can be sitting in front of the girls. Okay, so the boys don't have to be seated together. So this is what is really going on. I'm going to pretend that each boy is a group of his own. So the amount of ways that this one boy can be seated, I'll just call that 1 factorial, which is 1. But I'm just keeping it as factorial because for the sake of understanding in groups, I just want you to remember that we're constantly using factorials. And remember, we're multiplying these, okay, to find the amount of ways that they can be standing like this. Then this other boy, I'm also going to treat him as one group on his own, 1 factorial and 1 factorial and another 1 factorial. And remember, we are multiplying these. After that, remember that I'm just saying that this one boy, the amount of ways that he can be seated on his own like this is just 1 way. But then I can't just do that. The thing is, we have created a group for the girls, but the boys should still be allowed to sit in anywhere as long as they're not in between the girls. Meaning, this boy can sit here, for example. Or it could be a case where this boy can sit here instead, or even in between them. Now, to allow them to be able to move around freely, and even the girls themselves, because the girls don't have to be seated here. They could be seated in between, for example, these 2 boys, or in between these, okay? Now, to allow them to freely move around like that, we're going to multiply it by the amount of groups that have been created. So the amount of groups that have been created would be, this is the first group, this one boy will make up the second group, third group, fourth group, and fifth group. So we're seeing it as there are 5 groups. So we're timesing that by 5 factorial so that these ones can also move around. So these group of girls, for example, they don't have to be seated here. They can be seated all the way here. Okay. So that's what I'm timesing by the amount of groups factorial that they can be seated in. And so let's see what this gives. So you can simplify this. The 1 factorials, they really just make up 1. And when ones get multiplied, it gives you 1. If 1 gets multiplied by 5 factorial, it will just stay 5 factorial. So we have 3 factorial multiplied by 5 factorial, and that would be equal to, then we can just find out what that gives us. So remember the factorial button, we just say 3 and then you say shift and that, okay, factorial. Then multiply by 5 factorial, and that gives us 720. So there are 720 ways that these friends can be standing in as long as 3 girls have to be seated together. Okay, moving on to the next question, and this is the last question. The last question says 10.3.2. In the next photo, determine the probability that Selwyn, a boy, and Lindiwe, a girl, okay, will not stand next to each other in the photo. So the probability that they will not stand next to each other. So something you need to take note of, first of all, is that they are asking you for the probability. So not just the amount of ways, but the probability. Okay, so probability would be a fraction, for example. So let's just find out what that denominator of the fraction is. Like, for example, what if this question was, what is the probability that 3 girls will stand next to each other? Then we would have taken this, right, 720, and we would have put it over what? Well, you put this over the total amount of ways that the friends can be standing next to each other if they were not grouped in any way at all. And the ways that they'll be standing next to each other without any groups being made would be the amount of people that they are. There are 7 friends. So that would be 7 factorial. Okay, so I just want you to see that total, that denominator of whatever our probability will be is 7 factorial. Okay, so looking at this now, since they want us to find out the probability of the ways that this boy and the girl will not stand next to each other, how about we find out the amount of ways that they can stand next to each other? Then we'll be able to subtract that from the total ways that all these friends can be standing in this photo if no groups were being created. So let's find out the total ways that Lindiwe and Selwyn can actually be standing next to each other. So let me put down the illustration of the friends standing next to each other. Okay, so here are the 7 friends. And what we have to do is make Lindiwe and Selwyn sit together, or rather stand together. Okay, so here are the 7 friends. And remember, what we're trying to find out is the amount of ways, we'll talk about the probability at the end, that this boy and the girl will stand together. So will stand together. So to find out that probability, let's go ahead and group them together. So we need to make sure that Selwyn and Lindiwe are standing together. So one group has been made between them. They're going to be standing together like that. And then everybody else, I'm going to consider them as an individual group of their own. So the amount of ways that they can be standing together, despite the fact that they have to be one group, would be 2 factorial. And if you check that on the calculator, it's really just 2 ways. And the reason why is because the way they can be standing like this in a group is Selwyn can be standing first, then Lindiwe, or it could be a case where Lindiwe is standing first and then Selwyn. So you see that's 2 ways in total that they can be standing even as a group. Then we're going to look at everybody else as a group. So you make up one group, that makes up one group, and everybody else makes up one group. Okay, and remember we're multiplying all of these numbers. Then you have to multiply by the amount of groups factorial that has been created. Because of this, Lindiwe and Selwyn are one group. And then each person is a group of their own. So that's 1, 2, 3, 4, 5, 6 groups have been created. So I'm multiplying it by 6 factorial. That way, everybody else can move around. For example, this boy over here doesn't necessarily have to stand here. He can also stand in front of Selwyn and Lindiwe, or you could stand in between them. Okay, so that is to make sure it's not restricted like this. They don't have to be standing in this order. Okay, so what is that going to give? We can simplify that. This is going to be the 2 factorial, and of course the 1's just become 1, and 1 multiplied by anything really just stays the same. So multiply by 6 factorial. Okay, so let's go ahead and see what this will give. And remember, this is the amount of ways that they will stand together. So for that, I get 144 ways that they will stand together. Okay, now because of that, we'll be able to find out the probability of ways that they will not stand together. So if this is the amount of ways they will stand together, how much ways will they not stand together? Well, to find that out, we're going to find out the total amount of ways that everybody can just stand without any groups being created. And that would be the fact that there are 7 friends. That would be 7 factorial. That would be the total amount of ways they can stand without groups being created or any restrictions being made. Then we're going to minus that by the amount of ways that they will be able to stand together, where Lindiwe and Selwyn are standing together. That was 144 ways. So minus 144 ways, and that will give us the amount of ways that Lindiwe and Selwyn will not stand together. Okay, so it's really just the total ways that everybody can be standing minus the amount of ways that they will stand together. That will give you the ways that they will not be standing together. And when I calculate that, I get 3,600 ways. Okay, now remember, this final answer, it needs to be as a probability because that's what they asked for. So the probability that Selwyn and Lindiwe will not stand together would be this. This will be equal to this 3,600 ways over the total amount of ways that the friends can be standing if there were no restrictions made. And that would be the 7 factorial. That's the total amount of ways they can stand. So when we put this as a fraction, that should give us that probability. And so 3,600 over 7 factorial gives us 5 over 7. So 5 over 7 is our final answer. Okay, and that is the end of this paper.